Do you have mundane tasks that you have to perform on your computer from time to time? Do you wish that somebody else would do these for you? For example, maybe you take photographs rather frequently and you like to upload them to your blog, but before you do that, you have to resize the photos so that they're not giant for people to download. Are you familiar with using JavaScript to develop applications or to write some front-end code for websites? If so, then this course can help you take some of these mundane tasks that you have to perform on a daily basis and automate them to take the hassle out of your life. Now you might be wondering, why would I use JavaScript for this? Perhaps you've heard of other shell scripting languages or shell scripting environments like using Bash on a Mac, or perhaps using PowerShell on Windows. Well, there's nothing wrong with these environments and these languages for writing shell scripts. But the reality is, there's a lot of people that are familiar with JavaScript that aren't familiar with these other languages and environments for writing shell scripts. Why take the time to learn something new when you could use something that you already know really well? Especially when some of those mundane tasks might require the use of libraries and APIs that you're already familiar with. For example, if you wanted to write a shell script that went out to a website and scraped some data off that website, and then performed some calculations on that data, chances are, if you've worked with JavaScript on the web, then you already know how to reach out to remote websites, or web APIs at least, and pull down data and then manipulate that data. So you're probably already familiar with everything you would need to know to write a shell script like this. You might just not have thought of using JavaScript to do this. There are also quite a few good reasons beyond just the fact that you probably know JavaScript really well already. And one of those is that the shell scripts that you create with JavaScript, and we'll be using Node.js in this course to execute our JavaScript, these shell scripts can work great across various different platforms. You could run the same shell script on Windows written for Node.js as you can on a Mac. And the same script could be run on a Linux or Unix distribution as well. So the shell scripts you create aren't tied to a platform, whereas in most traditional shell scripting environments, you can run into a lot of issues between different operating systems and environments. So this is one less obstacle to writing a shell script that you could then reuse. Another big benefit, and one of the reasons we'll be using Node.js, is the wonderful ecosystem of packages that are available via npm. Most of the code you'll need to write your shell scripts, you can come out to npm and find people that have already created libraries and packages that'll do the heavy lifting for you, and usually it's a matter of simply composing together the packages you need to help you get whatever task done. For example, if I needed a shell script to parse a CSV file, well, there's lots of packages that can help me do that. And as you'll see in this course, pulling down packages with npm is very simple and straightforward. It's a matter of executing one simple command, and you can pull in code that somebody else has created and reuse it. I can't think of many traditional shell scripting environments that make it this easy to pull in packages. Another benefit of using JavaScript is that it's both object-oriented and a functional programming language. One of the challenges with traditional shell programming is that you're passing around strings and manipulating strings. You don't have nice object models for some of the data that you're working with, which can make it very complicated when you're dealing with anything beyond simple strings of information. In an object-oriented language, you can pass objects around instead. And the functional capabilities in JavaScript make it easy to create pipelines, as we'll see later in this course, to easily process data. In this course, we'll take a look at all of these benefits and many more as we work through examples of writing shell scripts in JavaScript. We'll see how to do things like generate files via templates. We'll see how to clean up XML files and pretty print the XML inside. We'll see how to take a set of images and convert them in batch down to thumbnails with a script. We'll also take a look at an example of how we can take data off of a website, process through it, produce averages, group datasets together, produce weekly averages, and do many advanced calculations with these datasets, and see how JavaScript can help make this a breeze in a shell script. As we go through this course, I'll help you connect with the traditional shell scripting concepts and how you can accomplish those using Node.js. We'll look at libraries that can help us with traditional shell scripting concepts to make them even simpler with Node.js. One in particular is ShellJS, a package out on npm that has functions like cd and pwd, things you'd normally use from the terminal or command prompt. We'll take a look at libraries that can help us parse out options to our programs so we can parameterize our shell scripts and make them much more reusable. And after we've created some scripts, we'll take a look at what it's like to package those scripts up and install them on other computers and share those with other people. And we'll do that by leveraging npm packages. And then toward the end of the course, we'll take a look at how easy it is to write some tests of the code that's inside of our shell script. So if we have some complexity in our shell scripts and we'd like to have some confidence that it works as expected, we can write some automated tests of that code. Before we get into shell scripting with JavaScript, let's take a look at shell scripting in general. On a Mac, you can access the shell by opening up Spotlight, typing in terminal, and then launching the terminal program. A terminal will open up, and the colors for you, if you haven't styled this yourself and you're on a Mac, will be white and black instead of yellow and black. I've changed my theme here. An interactive interface opens up with the terminal and launches the bash shell. And I know that because in the title of this window you can see bash. Bash is a common shell across many different operating systems, including macOS, Unix, and many Linux distros. From the command line, we can do things that are pretty neat. We can perform tasks that are otherwise somewhat daunting and tedious to do manually. For example, if I open up a website that has historical stock price data, and I scroll down here, I've loaded some data for November of 2015, and that data contains the stock prices for this Carriage Services Incorporated, CSV. Now, if I scroll down and look at the prices here, I can see the various daily closing prices for this stock. If I was interested in producing an average close price for the month of November, I could download this file as a CSV file. Now, I could open this up in Word, and then I could come to the close column. Right at the end, I could select the last cell. I could sum up the data above it. And then if I wanted an average instead, I could use the average function. And just like that, I can compute the average of the closing prices for the month of November for this stock. But if this is something I wanted to repeat, say on a daily basis, or if this is just something I wanted to do without pointing and clicking around in Excel, I could go to the command line. And then from the command line, I can change directories using the cd command into the downloads folder where I downloaded that CSV file. And then I can use the ls command to list the contents of this downloads folder. And inside of here, you can see table.csv, the file I downloaded from the Yahoo website. Synonymous with opening this in Excel, I can just print out the contents of this file with the cat command, passing the table.csv file as the first argument to that command. And you can see, I'm sure, what's familiar to you as the contents of a CSV file. And then from the command line, I can use a tool called awk to parse the contents of this file and search for information inside of it. For example, one of the things I can do is break up the individual lines by specifying a delimiter with a capital F flag, and then specifying that I'd like to use a comma as the delimiter. As awk goes through the contents of this table.csv file, on each line, the contents will be broken up whenever there's a comma. Then I can specify a program that I'd like to be executed upon the contents of this file. Inside of single quotes, I can specify some code to run as each line of the file is processed, and I can even specify code that runs at the start and end of processing this file. What I'd like to do is, when we're done processing the file, I'd like to run some code that prints out the average of that close column. And I can do that with the print command. And then awk is like a programming language. I can specify some variables. Now, I haven't declared these yet, but let's say that I have a sum and a count variable. When I'm done, I'll divide the sum by the count, which will produce the average. I can specify another block of code to execute, and this time, since I don't have an expression in front of it like end, this will run for every line or record in the CSV file. For each record, what I'd like to do is sum up the value of the close column. So I can set my sum variable equal to, and then I need to specify which column I'd like to access. Remember, we delimited the lines in this file with a comma, so each of the columns then are referenceable by number. If I look up in the header, you can see date, open, high, low, and close is the fifth column. So I can use $5 to refer to the value in the fifth column. I can use a semicolon to break and specify another action on each line. And the second action I'd like to perform is to add 1 to the count. So count equals 1, except I need to add the prior value of count, just like I also need to add the prior value of sum. This will produce a running total of the summation of the value in the close column, and this will just keep a count of the number of values we've processed. And then the last thing I need to do is specify what file I'd like to read into awk, so I can specify the table.csv. When I execute this now, I get a value back of 22.58. Now that doesn't quite match what we have in Excel, 23.71, and that's because we're counting the first record in this file, the headers. To fix for this, I can hit the up arrow to access the command that I just ran. I can go over to the point where I'm printing out the final result, and I can subtract 1 from the final result. So I'll decrement the count by 1 to exclude the header line. Now when I run that, I get 23.7155, which agrees with Excel. So as you can see, pretty powerful. From the command line, we can parse through this file and produce something complex like an average of the closing prices for this stock. We could create a little script and save it off to the side. I won't do that now because that'll be a bunch of unnecessary extra work. But we could create a script, put this command inside of it, and right before it, we could even put in another command to download the stock prices for any given month. And then on any given day, we could always pull back the last month's average closing price for a given stock. So we could build out a whole little script to do that for us so we don't have to do anything by hand by pointing and clicking in Excel. Next, let's take a look at shell scripting on Windows. On Windows, you have two options for accessing the shell. First, there's the older approach, which you can access by going to the Start menu and typing in CMD for command, and that'll open up the command prompt. This is a traditional approach. The second option is PowerShell. We'll take a look at that in a minute. Now, I've already gone ahead and downloaded the same file here on my Windows machine. And the default prompt opens up into my home directory, just like on a Mac, and I can use the same cd command to change into the downloads folder. But instead of ls, I now use dir to list the contents of the directory. Now, there are a lot of files in my download folder here, so I'm going to specify the file I'd like to list and exclude everything else. Not a huge discrepancy, but a difference between ls and dir. Now, if I want to dump out the contents of this text file, I can use the type command and specify the file, and I'll dump it out just like the cat command. Again, another difference that we have to keep in mind. Now, I'm not even going to try to parse the closing price and produce an average in the command prompt because I know that's going to be a nightmare. One of the hassles I've always had with Windows is the old command prompt was just no good in comparison to the bash shell on Mac and Unix and Linux distributions. Fortunately, there's a bit of a saving grace. PowerShell, which is not new by any means, but is new relatively speaking, is a much easier way to work with a shell in Windows. And you can just type in PowerShell from the Start menu to launch an instance of PowerShell. PowerShell opens up to the same location, and I can use the same cd command we've been using all along to change into my Downloads folder. And then inside the Downloads folder will be that table.csv. Now, one of the nice things about PowerShell is that many of the commands that you might be familiar with on a Unix distribution or Mac OS have been aliased to map from the familiar name like cat that you would use on a Mac to the respective PowerShell command to perform the same action. In this case, git-content is the command this will be dispatched to. The nice thing is we can use these familiar commands in PowerShell in many different situations, so we can use cat to dump out this table CSV file. Unfortunately, awk is a standalone tool, and that's not available on Windows, so we can't use that to parse the CSV file. Fortunately, working with CSV files is remarkably easy with PowerShell. In fact, there's an import CSV command that's designed specifically to parse CSV files. So I can specify my table.csv file, run this command, and as you can see, it's already parsed out the content of that file. And what we're getting back is an array of objects. One of the neat things about PowerShell is that it's an object-oriented shell. This is one of the strengths we'll have with JavaScript as well, in that we can work with objects instead of just strings that are passing around between commands. We'll see a bit more of that later on, but what we're seeing here is a dump of the list of record objects that came out of that CSV file. If I hit the up arrow, I can access that command again, and then I can take the output of that command and pipe it to another command. And piping is also a concept that's available in Bash that we didn't use. But what piping will do here is take the output of the CSV file, that array of record objects, and pass it on to another command. And PowerShell has a command called measure, or that's the shortcut for it. It's really measure-object. And this command will allow us to measure an aspect of the data that's passed in. In this case, what we'd like to do is access a property on each of those record objects, the close property, and we'd like to produce the average of the close property. And there we go. We have the average of 23.7155. By all means, I encourage you to learn more about the shells that are built into the OS because you'll want to use those at times. But then there are going to be other times where the things you're doing, you'll want to do those perhaps with JavaScript instead, or another scripting language. To help you out, I just wanted to take a minute and point you at this site, ss64.com. It has a great overview at the top here of the command prompt in Windows, PowerShell, and then Bash, as well as some specifics of shell scripting on OS X. For example, in Bash, we could open that up and access the awk command if we wanted to figure out what it was that I was typing in to parse that CSV file. There's also always great help available via many of these shell scripting environments. For example, if I wanted to learn more about the different things I could import, I could tab through the commands, or I could specify that I'd like to get some help about import-CSV. But again, one of the big benefits about considering using other languages besides what's available in the shell that comes with your OS is that you're already familiar with those language constructs if you're using JavaScript on a daily basis. So you don't have to access help files as much, and you don't have to wonder as much about how you go about doing something. And perhaps most importantly, if you'd like to reuse these scripts across different operating systems, you wouldn't have to rewrite them to make sure that they work on every OS that you'd like to target. If you're working with JavaScript, you can use standardized libraries that will work across all the OSs you're likely to encounter. Now, that's not to say that you wouldn't have occasional cross-platform issues, but by and large, you don't have these issues of discrepancies where you need to use the type command to dump out the contents of a file versus the cat command on a different OS. Or that in PowerShell, you'll have to use import-CSV instead of awk, and then the measure command instead of an awk program to produce the average. Running JavaScript in a browser surely isn't a challenge. The idea with JavaScript shell scripting is, let's take this environment in which we can write JavaScript, a language we're very familiar with, let's take it out of the browser and bring it into something more like the command line. Wouldn't it be great if we could type in some JavaScript here right in the command line and use a language and constructs that we're already familiar with? If that sounds far-fetched, well, it really isn't. In fact, one of the challenges you'll probably face, at least initially, is deciding what you might want to use to run JavaScript outside of the browser. The answer is definitive in that we'll want to use Node.js, and that's what I'll use throughout this course. But I'd like to point out that there are many, many standalone environments in which you can run JavaScript outside of the browser. There are just a couple of these listed here on this Developer Mozilla page. Now, I've chosen Node.js for a couple of reasons. I want to point these reasons out, first off, so you know that there is a choice. But second, in highlighting why we'd use Node.js, we can understand some of the benefits we can obtain by using JavaScript to write our shell scripts. Now, probably the number one reason to use Node.js is its overwhelming popularity as an environment to run JavaScript on the server. And the reason it's popular introduces a second benefit of using JavaScript to write shell scripts. And that's the benefit around the Node.js ecosystem. NPM, the Node Package Manager, is backed by a repository of almost endless possibilities to reuse code that other people have already written. Code that will, I guarantee you, in any situation where you want to do something small at the command line, you'll easily find something you can reuse that already exists so that you don't have to create things from scratch every time. For example, if I wanted to parse a CSV file, I know if I just put CSV into npmjs.com, I'll find many different packages that can help me work with CSV. Right here at the top is a CSV parser. Not only is all this great code already available, but the ecosystem around NPM and the tooling itself makes it very easy for you to reuse your own scripts that you'll create. And we'll see that later in the course when we talk about sharing our scripts with other people or just moving our scripts around easily from computer to computer so we can reuse them. You'll see it's very easy by packaging up your code as Node.js packages to reuse it. This gives you an added incentive to write a shell script because you'll be able to take advantage of it in the future. And maybe one last benefit before we move on. Node.js was developed to be highly modularizable. What do I mean by that? Well, if we scroll down here looking at the CSV package, you'll see an example down below. And at the very top of this example is a line that has a require function call and passes the name CSV as a string. If you've worked with JavaScript in the browser, unless you're working with some of the latest improvements in ES6 and modularity at this point in time, and also layering on tools like System.js or Webpack to be able to import modules in a browser, you know that traditionally we've had to write script tags to be able to import JavaScript code. So if we had a library like a CSV parser, we'd have to have a script tag for that on our page. And I'm sure you know those script tags can easily get out of hand. It's not hard to end up with a ball of spaghetti. Node.js gets around this by adding this construct of a require function whereby you can import other JavaScript code right inside of JavaScript code. And the beauty of that is then individual JavaScript files are coupled together and you understand the relationship between them. There's no more script tags. You simply have your JavaScript file here, like this example, and Node.js will go off and fetch this package wherever it might live and import the code for this package so that you can use it to parse CSV files in a shell script you might be creating. These are some of the primary benefits of choosing Node.js as our environment to run JavaScript outside of the browser. Next, we'll take a look at how we will install Node.js on our machine. And first, I'll cover how to install it on a Mac. And even if you don't have a Mac, I encourage you to watch this clip because inside of this clip, I'll explain a little bit about which version of Node.js we want. And I'll talk a little bit about the history of Node.js. Right after that, I'll show you how to install it on Windows. And in addition to Node.js, you'll also need a tool to edit your JavaScript. I'll talk about that too. On a Mac, you can go to nodejs.org to grab a download to install Node.js. Now you have two choices, version 4 on the left, version 5 on the right. In the future, these might be bumped up and be higher versions, and that's fine. In this course, we're going to use 5.1.1, the version on the right. So long as you use a greater version than that, you should be able to follow along without any problem. Now, before I walk through the installation of this, click the link called Other Downloads because I want to take a minute to talk about the version history of Node.js. If we go up a directory here, we can access the past versions of Node.js. If we scroll down here, you can see there's a v0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up through 12. For a long, long time, Node.js was versioned with a major number of 0 and then incrementing minor numbers, where the minor number being even or odd dictated whether or not the release was a stable release for long-term support, or the release was, while stable, not going to be supported long-term because the odd-numbered versions were a development branch, if you will, whereby new features were created, tested, and then finally solidified into a future even number that would be a long-term support branch. Long story short, if you come back to the home page, you'll notice, though, these versions are no longer prefixed with a 0 major number, but with 4 and 5. Scroll down. Rather recently, versions started to be released as 4.0. There's a jump between 0.12 and 4.0, and that might seem a little bit odd, so I wanted to point it out. What happened was Node.js was forked into IO.js for a while. Long story short, those two communities came back together under the Node Foundation, and when IO.js was merged back in with Node.js, the version of Node.js had been bumped up to v4 to match what had been developed in IO.js. IO.js had gone ahead and started to increment the major number because IO.js adopted a semver style of versioning, where breaking changes would introduce a major increase in the version number. So IO.js had been off developing v1, 2, and 3 of Node.js, really, and then those got merged back together in v4. And now the new versioning strategy in Node.js is to have a long-term supported release of Node.js at any one time, and also to have a more short-term, while stable, it's a short-term release not meant to be supported in the long term. And at this point in time, the long-term supported version is v4. The short-term, more bleeding edge version is v5, though there's nothing wrong with using v5, even in a production environment. In the future, you'll see this as v6 and v7, etc. So v5 will eventually morph into a stable version of v6. A great resource for more information about IO.js and Node.js merging back together is the release notes for v4 on the Node.js blog. You can read through this if you'd like to know more about what exactly happened in the history of Node.js. To install Node.js on a Mac, simply come back, choose the release you'd like, download this. The download will be an application package. Go ahead and click that to open it up. And then let's walk through the installation process. Go ahead and accept the terms of the license agreement. You can choose who you'd like to install it for. I'll choose for all users. You can change the location if you'd like. And then go ahead and click the install button. You can customize, but I prefer if you just leave the defaults for working through this course. That will kick off the installation process. It'll tell you where Node.js was installed at. You can take note of where it installed in case you have any trouble, but this is going into user local bin, so everything should be fine. It's telling us we should make sure that that's in our path, but it's already in our path, and I'll show you how to check that just in case you have a problem with it. But go ahead and close the installer, and then launch the terminal that we just worked with. The bash shell will open up, and from here you should have access to a node command. Run that, Node will run with an interactive prompt. You can choose Control-C twice to kill that. You could also just type node-v to get the version number, and that should match 5.1.1. The other tool is npm. Call that with the -v flag. Check your version out. I'm using 3.3.12 in this course. If you have any trouble with the course because of a newer version of Node.js, you could always revert back and install one of the older versions, again, on the other downloads link on the download page. But there really shouldn't be anything we're going to cover in this course. It will be problematic in the future. How did these commands become available? Well, that's where the path variable comes into play. And if I just type in $path, Bash will output my path. And you can see inside of here /user/local/bin is already in the path, and that's where Node.js is at. As for editors for working with JavaScript, I'll be using WebStorm throughout this course. You can use any tool you would like, whatever you're familiar with already, just stick to that. You could also try WebStorm out if you would like to try something new, but anything is fine. Sublime Text is a great editor as well. Or if you love the command line, VI, Vim, any tool from the command line can work as well. Go to the same nodejs.org website to download Node for Windows. And then again, down on the bottom, click the v5.1.1 stable release, or choose either of these downloads based on when you're watching this course, so long as it's greater than the 5.1.1 release. Click on that. That'll download an MSI to install Node.js. When you open that up, just walk through the dialog, accept the license terms, choose where you'd like to install to, leave the default options, and then go ahead and install Node.js. Once that's done, you can go ahead and close the installer. And then to access Node.js, you can use either PowerShell or the Windows command prompt. Go ahead and close out the instances you had open if you are following along with processing that CSV file. Close out the instances because you'll need to reopen either of those two tools. I'll be using the command prompt here. You'll need to reopen that tool so the updated path, which includes the location to Node.js, is accessible, so you can type in node then from the command line. You can use the -v flag to ask for the version of Node.js, and you should see the version that you selected when you downloaded it. If this doesn't come up, that might be an indication of a problem with the installation process and you'll want to try again. One other thing you can confirm is that you have access to npm, another tool that comes along with Node.js. This is the Node Package Manager. And I just want to point out the version I'm using here, 3.3.12. In the future, if you were to have any problems with updates to Node.js or npm, you could revert back to using the versions in this course to follow along without any hassles, though there really shouldn't be. And then you could always bump up back to whatever version you'd like to use once you're done with the course. In fact, if you want to be able to run multiple versions of Node, you can look for a tool called NVM, the Node Version Manager. And if you scroll down into the installation instructions, NVM is meant for Mac OS and Unix environments, but you can click on NVM-Windows to access a Windows version of this. As for tooling in Windows, you can use any editor that can edit JavaScript. If you don't have a preference, Sublime Text will work nicely. Or, as I'll be using on a Mac, WebStorm is a great tool to edit JavaScript as well. Let's take Node for a little spin here. Let's say that when we write blog posts, we need to create a file that includes the current date and time in the file name so that all of our blog posts are easily referenced by when we created them. To do this, the very first thing we would need is to somehow get access to the current date and time. In Bash, we can do this with the date command. But as you can see here, this probably isn't a good formatting for our file name. We'd like to somehow come in here and clean up and specify a different type of formatting. Now, if you go to ss64.com, and if you click on OSX, you should be able to find a date command. You could click on that, and you'll have information about what you can pass to the date command. Now, the other thing you could have done right here from the shell is something like info date to get information, or you could look at the man page for the date command. The reason I wanted to point out ss64.com, take that link, open a new window, and change from OSX to Bash in the URL. You'll pull up the documentation for the date command and the generic Bash shell. And what you'll find is that there are a different set of flags here. And the difference is, in this case, these are flags specific to the Mac version of this date command versus the flags you'd likely use on a Linux distribution. So even the date command being the same doesn't mean that all the flags you pass to it are the same. So this can be a big hassle. In fact, in trying to figure out how to do this, I stumbled on many different pages where people are griping about the fact that this command is used differently on different OSs. So what we'd like to do is call the date command and pass a set of formatting to this command. And when we run that, we now get this nicely formatted date. The only problem is if we wanted to reuse this across different OSs, we're going to have trouble with that. The nice thing about JavaScript, and this is one of the benefits again, is that the date type in JavaScript will work the same across different operating systems. Let's take a look at this in action. Now, the node command, when we first ran it on the Mac, and if you just run the node command right now, it'll open up an interactive shell, a REPL, where you can interact with Node.js, a JavaScript environment, without even needing to write a JavaScript file like you're familiar with doing in the browser. This is just like the bash shell in many ways, except that you can now work with JavaScript. For example, I could write console.log, and I could say hello world, and print out hello world. That also means I could come in here and print out the date. Now to format this date, we'll turn next to installing an npm package and using that to help us format. Now we'd like to format this date inside of Node.js to match the format we had used at the command line. To be honest, JavaScript doesn't have good built-in date formatting, but that's okay because I can demonstrate one of the great benefits of working with Node.js. Go ahead and type Control-C twice if you're following along to kill the Node.js REPL and go back to the command line. I'm going to make a directory here and go inside of it because I need to download some files here in a minute. So let's make a directory called test. Let's change into that directory with cd. So mkdir makes a directory, cd into it. And then inside of here, there's nothing inside of this folder at this point. What I would like to do is format that date in JavaScript. Now to do this, I already have a great package I'd like to share with you. I can go to npmjs.org and search for it. And even if I didn't have a package, I have a sneaky suspicion if I just put in date format, I'll get something that would help me out. I've got one in particular I'm looking for called moment. It doesn't look to be coming up in the very first results here, so we'll put that in instead. This is one I've used a lot in the past. Click on the first result called moment. This is a library to help us work with dates. Specifically, I like the part of it that helps us display dates. If I click on the GitHub page, that's the repository for this moment module, Node.js module, and scroll down, you'll see the same notes, but there's a link there to momentjs.com, which is a great reference for the documentation for this module. What I'd like to do is pull this down and use this to format that date in Node.js. So how do we do this? All we need to do to use this is go back to our terminal, and then we'll call npm, which is the Node package manager, pass install as the subcommand, and then pass the name of the package that we'd like to install. In this case, the moment package, which is exactly the name of the package out on npmjs.com. Run that command. The package will be downloaded. Now you might get back a warning that there's no package.json. You can ignore that for the time being. If we list the contents of our directory, you'll see a node modules folder. And if I cd into that node modules folder to change into that directory and run an ls again, you'll see a folder called moment. I can cd into moment, ls again. And these files here, the license, readme, ender.js, moment.js, and a few other files as well, are files that are right from the moment.js project. And you can see the same files out here on GitHub for this project. Or a similar set will be accessible right here from the repository. If I split the screen, you'll see license and readme, for example. License, scroll down, readme, moment.js, ender.js. Select components are pulled out of this GitHub repository into this node package that's accessible via npm. We don't need to go into how that works at this point in time, but more or less we've pulled down this moment.js JavaScript file, which is something you should be familiar with. Just like if you were to include this on a web page, perhaps you've even used moment.js on a web page before. So this file is the same moment.js we have right here on our disk now. Now, the nice thing is you don't have to know about any of this. I just wanted to poke into it for you so you understood what's there if you're not familiar with it. We can go up a couple directories then back into our test folder, just right next to where that node modules folder is at. And right from that test folder, next to that node modules folder, kick off Node.js again. Now we're still in the REPL mode. If you hit the up arrow, you can access the last command, which is that logging of the date. We can run that again and see the format we have right now. Now what we'd like to do is use moment to format it. First, we need to import the code for moment.js. And to do that, we can define a variable called moment. And then we can use that require function I mentioned earlier to require the moment package. When we execute that, that variable is now accessible inside of our Node.js REPL. You can type moment and hit tab to complete that. If you hit return, the contents of that variable will be printed out, and you can see we've got an object here that has a bunch of functions and other bits on it that will help us print and display our date in a desirable format. I'm going to do two things. I'm going to go up and grab the date format as it is, just so we can see how it was unformatted. Now, what we can do to format the date with moment is to first create an instance of a moment object. So that moment variable is a function we can call. And then we can call the format function on the moment instance. Moment instance is a date instance, if you will. It's just a wrapper around this special type, and it has a format function then. And into that format function, we can specify formatting. So I'll add the year. Print that out now, and we get the year. So all we've done is create a new type that's a date, more or less, this moment type. And we've called the format function. If I call it without any string, you can see we have the full date and time. I've pasted in a format string here to print out the date and time in the format that we were using before. And there you go. That's how we can custom format the date. And the key here is not that we can custom format dates in a nice way, or that this is even somehow superior to using the date command. The key here is that we are able to go out and grab some code that somebody else wrote and easily pull it in with a simple require statement to be able to pull it in and use it inside of our Node.js REPL. So we have that entire ecosystem of packages available at our fingertips. And think about that a minute. Those are all the packages people are using primarily for some intensive server-side JavaScript processing. And there's actually a lot of front-end JavaScript packages out there as well. So all the things you would be doing in web development are accessible to you now in your shell scripts. Working with JSON, making web requests, calling out to web APIs, working with XML, templating engines. These are a few of the things that you have at your fingertips now. By the very nature of using JavaScript with Node.js, we really have an object-oriented shell versus shells like Bash or the old command prompt in Windows, where you're primarily working with individual standalone programs, and then the integration mechanism between the programs is to pass strings between programs. So for example, the cat command, if I wanted to use that to print out the moment.js JavaScript file, prints out a string. Now, if I wanted to do something else with that string, I could pass it, say, to the grep command, which would then allow me to filter through the contents of this file with a regular expression. So for example, if I wanted to find that format function we were using, I could type in format as my pattern to match. Scroll up here then, you can see the function for format. But at the end of the day, we're just passing strings back and forth between programs, which means we constantly have to think about how we interact with strings. And strings are not a very representative structure. However, in JavaScript, if I run the node REPL again, and if I import the moment package again, if I was curious about that moment instance that we were creating, I could create it. And by the way, I don't have to specify console.log to print out the results. And in this case, the moment instance is printed out, and we can see a list of some of the properties on this object. And as before, we called the format method. And if I take off the parentheses, we can see that's a function. So we're working with objects here. When we start to work with objects, sometimes we have much better control over the manipulation that's occurring. This benefit isn't unique to using scripting languages like JavaScript with Node.js, but PowerShell, one of its strong suits is that it's also an object-oriented shell. Instead of strings being passed around, objects are being passed around. Can you think back to a time where you had to do something at the command line that was rather complex? And maybe you did go through the process of piping information back and forth between different applications. Imagine what it might have been like if you had objects that were passing back and forth that had functions and properties accessible that you could manipulate instead. And imagine if you had something interactive like this node REPL where you could inspect some of these different functions and properties you could be using. For example, when I make that instance of a moment, let's say I wanted to figure out what the date would be 1 week from now. Say I needed that for some purpose. Well, it turns out moment has an add function. And when I call that add function, I can pass a number, say 1 week. And then the second value, I can pass a string with week, in which case I can produce the date and time a week from now. When I run this, you can see, and I didn't format this nicely, But you can see the D property on this moment instance has a date of December 11th, 2015. And here's the prior one, December 4th. So today's December 4th. There's a week from now. That's all I have to do to figure out what the date and time is for 1 week from now. I challenge you to go out and figure out how to do that using the date command and perhaps other commands with bash. It's not going to be pretty. But this moment library is a really rich API. And unlike reading some obtuse help file, you can just peruse through the functions on the object here right at the command line using all the techniques you're already familiar with JavaScript to figure out what you can do with this moment instance and how you can use it to interact with other object-oriented APIs in JavaScript. Now, the really neat thing about all this is that what we've just done here on a Mac will work just the same on Windows. So I can hop over to my Windows machine here. I can make a directory called test, cd into that. Inside of there, I can run npm install moment to grab the moment package. I can start up the node REPL. I can import the moment package. I can create an instance of moment. And voila, I have access to all the same functions I've been using. So if I created a script here that could create a blog post for me with the name of the file, including the date and time, I could use this on Mac, Linux, Unix, Windows, really any OS that can run Node.js, I can reuse this code there. Which means it's much more likely that I'll take the time to write a shell script because I won't be inhibited based on the environment that I want to run it in. Now that we've seen how to use Node.js as a JavaScript shell, in the next chapter, we'll turn to writing shell scripts in a JavaScript file, much like you've done with web development, and how to run those with Node.js because we wouldn't want to work in this interactive REPL all the time and have to constantly type out all the code every time we need it. Be nice, just like with a bash shell script, to be able to write a Node.js shell script and keep it around. Thus far, we've been working with Node.js from the REPL, which, while convenient when we're first poking around and getting used to it, is not a great way to reuse what we're working on. We have to type everything in every time we want to use it. If we want to import a package, we have to rewrite the import declaration for that. In this chapter, in addition to looking at how we can take what we're doing in the REPL here and putting it into a JavaScript file and seeing how that runs with Node.js, we'll also start to look at the various concepts that are helpful when we're writing shell scripts and how we can map those concepts into Node.js land. This will be a great introduction for you if you're not too familiar with Node.js to see some of the things that are specific about the JavaScript environment that Node.js hosts versus a JavaScript environment in a browser. So first, let's go ahead and take that script we were working on to print out a date. Let's continue working on it to create our blog post, but let's do that with a JavaScript file that lives outside of the Node.js REPL. So I'm going to kill the Node.js REPL here, and then I'm going to go over to WebStorm. Now, again, you can use any JavaScript editor you'd like. I'll be working with WebStorm. I'm going to make a new project here, and I'm going to call this JS Shell. Now, inside of this project that I've created, I'm going to add a JavaScript file, and you can create one of these with whatever editor you're using. Let's just call this file blogpost.js. Perhaps a better name for that would be generate blog post. Inside of the script, we'll use this to generate a template of a blog post, and we'll do a couple of things. First, we'll set the file name to include the date and time. And then also we'll put some meta information at the top of the post that our blog engine could theoretically parse, including the date and time, a field for us to give a title to the post. And while we're at it, we'll tack on the current user that's logged into this machine into the header so that we don't have to type that out every time we start a blog post. But before we get there, let's just recreate what we have at this point. We were using that moment package to format our date and time. So let's go ahead and type in the import for that using the require statement. All right, the next thing we need to do is install this moment package. I'll open up a terminal, and then I will cd into the location where I created my new JavaScript project. You can see there's the generate script. So I'll run npm install and type in moment for the moment package. And if I list the contents of the directory, you can see the node modules folder, and there's the moment folder inside. All right, now that the package is included, we can go ahead and use it. Unlike the REPL, where we can just write out the contents of whatever we type onto a line, we do need to use console.log here to be able to output a date. We can create a new instance of the moment type, call the format function, and then I can paste in the format. That's all we should need to do to print out the date formatted for our file. Go back to the command line. I'm going to clear the screen here. Now, instead of opening up the node REPL, we can simply call the node command and pass to it the script that we created. The contents of the script will be executed, and in this case, we print out our date and time. So we've now caught ourselves back up to taking what we were doing in the REPL and getting it into a file so we can reuse it. The next thing we want to do with our demo is access the current user logged onto the computer so that we can put that into our blog post. But to do that, we need to understand a little bit more about the hosted environment that's available via Node.js. So next we'll turn to looking at the global object in the Node.js environment. If we'd like to use that username in the header or meta information for our blog post, we'll need to find a way to access who we are when we're logged on. You can see here in my prompt in the bash shell that my name is included. I'd like to use that as the author name for the blog post because it's a blog post I'm writing. I don't want to have to type that in every time. It turns out that the username is available as one of the environment variables, and perhaps you've used this before in shell scripting. If I dump out the environment variables for my computer here, you'll see there's a user environment variable with my name in it. That's how I'm able to have my name in the prompt. I'd like to use this from my Node.js script. To use this requires understanding the objects that are available in the global context within Node.js. Inside of a browser, no doubt you're familiar with the fact that there's a window global object that you can access. So if I open up a console, I can type in window, and this is a global object that contains information about the browser window. It's a global object in the context of a browser that's hosting the JavaScript. Obviously, it wouldn't make sense for there to be a window object in Node.js because there's no browser window. Another global object is the console object that we use to call console.log. Within a JavaScript execution environment, whether it be a browser or Node.js or any other, there are global objects that we can use. So if I spin up the Node.js REPL again, I can type in browser, but that won't return anything. It's not defined. However, there is a global object that is defined. This global object is much like that browser global object. It has specific things that are available to us within the Node.js execution environment. For example, on the global object is a property called process. It has information about the process we're running. And then on that process object is an environment property. And this environment property is an object that contains keys and values that are mapped to properties on this environment object. So you can see on this environment object, there's a user property with the username, just like we saw at the command line when we use the environment command inside of a bash shell. Now there's a lot that's available to you in this global object and its nested properties. The best way to figure out what's available is to refer time to time to the documentation for Node.js. So if you go to nodejs.org and click on Docs, and then go under API, shortcut would be nodejs.org/API, there's a set of documentation to everything that's built into Node.js. And right now, we're looking at globals. So if you click on the globals documentation, you'll have access to information about what's available in the global context. So here's the global object that we just took a look at. And as it turns out, the process object is also available in the global context. Even though we can get to it from global.process, we can also just type in process and get to the same point. It's a shortcut. So this documentation contains all of the globally available objects and functions too. For example, the require function that imports a module. If you scroll to the top, you can see a list of everything that's available. You'll also see console, just like in a browser, and setting intervals and timeouts and clearing intervals and timeouts, functions that are also available in a browser. So let's go ahead and use the process global object to access the environment variables, and then get our username. We'll take a look at that in the next video. So let's go ahead and copy the environment variable for our username and go over to WebStorm. And let's create a variable that holds this. So username is what we'll capture from the process's environment variable for user. And then we can also go ahead and create a variable for the date. And I can do that by extracting a variable using WebStorm's built-in refactoring. And we can call this date. So we've got the date and username variables. We have a nice script starting out. We've got some clarity in our variable names. which is, again, one of the benefits of using JavaScript. It's easy to isolate and abstract away portions of your program and give them meaningful names. In fact, I think that's something most people are familiar with doing when it comes to writing web applications and writing more robust applications in software. But I tell you what, a lot of the time I see inside of shell scripts, because people see them as just a little stopgap temporary solution, there's not a lot of care put into naming things, which can make those scripts very hard to understand in the future. So let's build up what would be contained inside of our file for the header or meta information about our blog post. So let's print out some information here. Do a console.log, and then let's say we're going to print out the date first. And let's say the meta format for that is a -- date : and then we want to specify the date string that we built. Now, WebStorm's complaining because I'm trying to use a new ES6 template string, so I need to tell WebStorm that I'm using ES6. I can go into the language version and set that. You might need to do that in whatever IDE you're using if you want to follow along and use a template string. Once that kicks in, then WebStorm's allowing me to transpile this down to vanilla JavaScript, and I'm going to leave it alone. We don't need to do that. One of the nice things about the new version of JavaScript in ES6 and future versions is that we have a lot of nice syntax features coming. For example, template strings, which are really helpful in logging information, which is something you'll do a lot of inside of shell scripts. We don't have to add together strings, so we don't have to come in here and add our date variable. We can instead embed it right inside of our template string. And then the next line, let's assume that this will be a line that includes our username. Again, -- and then user, let's assume that's the format. And then we'll reference the username that we get from our environment variable. Then the last piece of meta information, the title. We'll leave that blank because that's something we'll fill in. And then let's assume that we need to print out an arbitrary number of dashes to somewhat separate this information from the rest of the file. So this would be the header of our blog post. Let's take a look at that looks like when we execute it, make sure everything's okay. Let's kill the node REPL, clear the screen here, and let's just run our generate blog post script again. And there you go. We've got a date with the date and time, we've got the username, and we've got a title. Next, we'll take a look at how we can save this information to a file by turning to looking at the fs module in Node.js. Writing to a file is a pretty typical operation inside of a shell script. And to do that in Node.js, we need to access the file system module. If you go over to the API and you click on file system in the left, and the reason I called this fs is because that's the name of this module when you require it or import it. So it's a typical shorthand for this module. This module has many, many different things available on it. What we're looking for is the fs.write file. And there's two versions of this. One is an asynchronous version and one is a synchronous version. Now, if you've worked with Node.js or JavaScript in the browser, you know that it's pretty typical to use callbacks with asynchronous code. But one thing I want to point out, when you're in the context of a shell script, you're not usually too worried about the asynchronicity of your code. You're usually running this on your local computer to perform some tiny little task for you, and you're usually waiting for it to complete before you do anything else. So there really isn't any need or concern in a lot of cases with a shell script to worry about asynchronicity, and instead I'd encourage you to always use synchronous API methods when available. And watch out for this in the file system API. And the reason I recommend this is this will keep your code much more concise and clear because you won't need to transfer control to a callback. So let's click on fs.write file. If we used this version, the asynchronous version, the rest of our program execution would have to happen inside of the callback code block. It'd be nested in permanently for the rest of our script, and that can be kind of ugly. We don't have a need to do that, though. We can simply use the write file sync method instead. So I'm going to copy this over so we can use this. I'm going to go back to WebStorm and paste that in. Now we need to import this module, so let's come to the top, write a require statement, and require fs, the fs module, the file system module. Now we can access the write file sync method, and what we would like to do is use the date as the file name, but let's add a little bit more on here. Let's assume that this is a markdown file that we're creating. So we'll use the date, and we'll append a .md for markdown. Then the data for the file, well, that's what we have here that we're writing out to the console. So let's build up a string for that instead. So what we can do is get rid of our log statements, come here to the console.log. We can create a variable instead, call it header for the header of our blog post. And then let's just get rid of these calls to console log. And instead what we can do is create a multi-line template string literal. And maybe just to keep this a little more succinct, we'll leave a blank line at the very top of this header. So the header is what we'll want to write to the file. We'll get rid of the options, close that off with a semicolon. So we now have code set up that should create a file with the file name being the date, a markdown extension, and then our header information. Let's save this. Let's go over to the terminal, and let's run our script again and see what happens. No output, and that's to be expected. If we list the contents, we have our 2015 12 04 17 29. So the file name looks great. Let's cat the contents of that. And it looks like we have our header information. Looks like everything is working great. If we run it again, and we list the contents of our directory, well, it looks like the time hasn't changed. So we're probably writing over the top of the file that we had just created before, which might not be desirable. What we can do to check for that and not wipe out a blog post that we've created is to take advantage of the fs module's exist function. And again, watch out for an option for a synchronous version of this. We don't want to nest our code yet again, so use the exist sync. So we'll come over to WebStorm before we write the file. Notice I'm getting some help here inside of WebStorm, one of the reasons I also like to use it. It has IntelliSense for Node.js APIs. And then we can go ahead and extract a variable for the file name. That way we can reuse this to see if that file exists. All right, now if that file doesn't exist, we'd like to go ahead and create it. But if it does, perhaps we should warn about that. So we can create an if block, use that file.exist check inside of the if block. And if it does exist, we can print out that the file exists and we've got a problem. Maybe it's not a problem. Maybe we're just warning the user. That's okay. Now if we go to the shell, run our script again, run it again. There we go. The second time we ran it, now that the time is the same, we get an error, file exists. List the contents of our directory, we can see the second file that we've created here. Maybe it'd be a bit more helpful to see what file already exists. So we can convert this to a template string and include the file name. Now when we run it and we get the error that tells us what file exactly already existed so we don't lose our mind. Now that we've got an opportunity to talk about errors in our program flow, it'd be a great time to talk about the different ways we can output information as our script is executing and when it completes. We're using console log to tell the user that we've got a problem. We probably also should use console.log to tell the user what file we created. That way they can keep their head on straight about which blog post it was that we created for them. I'm sure you're familiar, though, in addition to the standard out, which is what console.log writes to, there's also a standard error for every process that runs on a computer. And when working with other shell scripts, I'm sure you've encountered this as well. At this point, everything logs to standard out. And to see that, let's go over to the terminal. And when we run our script, we can redirect the output to text files instead of to the console here. Now, for the output of a program, there are two separate streams, and you could think of these as two separate pipes. There's one pipe that comes in, that's the standard input. There are two pipes that go out. There's the standard out and the standard error. These pipes have file descriptors. One refers to standard out. So let's pipe that out to a file called standard output. And then 2 is a file descriptor that refers to standard error. So let's pipe that out to standard error. When we run our program now, nothing will come out to the console here, even though we know we have a message telling us whether or not we created the file. And instead, the output goes to one of these two files. Can you guess which one? Clear the screen here. Let's list the contents of our directory. And I'm going to output each of the files. So first, standard error, nothing in there. Second, standard output. And there we have creating our blog post. Now let's run our script again. See if I did this quickly enough that we'll have an error. Let's check our two output files again. Standard out has creating, standard error has nothing. So I ran that a little bit too late. Let's run it again so we get an error this time. Print out standard output. Okay, so in this case, even though we have an error, you can see it's still coming across in standard output, and that's because we've been using console.log the entire time. So with console log, the output always goes to the standard output. However, if we use console.warn instead, let's take a look and see what that does. So we'll warn when the file already exists. Come back to the terminal. Let's run our generate blog post again. We'll cat the standard out, and we'll cat the standard error. This time it created successfully, and that's in the standard output. Let's run it again real quick so we get an error, hopefully. Cat the standard output first. And now there's standard error. Now that we use warn, when the file already exists, our message comes through the second pipe, which is standard error. See how we have standard error here? Whereas before, when we use log, it always went to the standard output. So we can differentiate details or debug information and send that to the standard output. And then we can split off any warnings or errors and send that to the standard error instead with console.warn. Now you might be wondering, well, what happens without these redirects on here? So I'm going to drop the redirects. Let's create a new blog post. Creating, run it again, error file exists. So by default, without any redirects, both standard error and standard out are output here on the screen for you. I'm just using these files so we could capture them separately. This is a way, if you will, to tap into each of the separate pipes with these redirects. I mentioned this to you because by convention, warnings and problems should go into standard error, because that's a way that people can find out when they're running your program if something went wrong. A lot of times people will listen to standard error separate from standard output. In fact, as you've seen here, we can redirect these to different files, which could be really helpful when debugging something that goes wrong with one of your scripts. Next, we'll take a look at exit codes. In addition to standard error, when something goes wrong with the program and it terminates unexpectedly, for example, if a program needed to take information in from a file and that file doesn't exist, or maybe in our case where we're writing to a file and it already exists and we don't want to replace it. In addition, we might also want to set what's known as an exit code to let the environment that's running our program or script know that something really bad happened, that things aren't okay, and perhaps somebody should take a look and see what had gone wrong and see if there's a bigger problem to deal with. So exit codes are the way to do that in addition to printing information about what went wrong with console.warn, which goes to standard error. To figure out how this works, inside of bash, if we run a program like echo to echo out A, so it just prints A out, and that will work on Windows as well, the echo command. If, however, we make a typo in echo, the command isn't found, and if we look at a variable, the $question variable in bash, if we echo that out, we can see the value is 127, which is a non-zero exit code, which means something went wrong. However, if I up and run this again, you'll see that we get 0 because the echo command that printed out the non-zero exit code, I know this is somewhat confusing, succeeded, so it had a successful return code, which is a 0 value. In other words, when everything goes okay, then the value will be 0. If, however, we have typos, then the value won't be 0. So perhaps we'd like to replicate that in our program. Perhaps, in addition to warning, we'd like to exit with a non-zero exit code. We can do this with that process global object we can call the exit function, and we can specify the value we'd like to use. Now, the value truly is up to you. In this case, I'll just use 1 to indicate a non-zero exit code. The key here is that your program returning with a non-zero exit code means something went wrong. Usually programs will have lookups that specify what the different exit codes mean. However, a lot of times they'll also print out helpful information like an error message. If we go to the command line and we run our script now, we run it again to get an error, look at the exit code. I messed up that command. Let's run our script again and we still have an error. We have to echo the variable for the last exit code. We can see the value is 1. And if we run our script again, still get an error, so the value is going to be 1. All right, I fast forward in time here. Now let's run our program again. When it's successful, you can see the exit code is 0 because that's the default. This will become especially important if you want to take any of your shell scripts and perhaps schedule them to run on a regular basis, and you'd like to know if something went wrong. Your scheduling program oftentimes can respond to a non-zero exit code and alert you about it. Various different systems are tuned into the fact that a non-zero exit code means there's a problem and will usually pass that on. All right, I think we've spent enough time talking about dates and blog posts. Let's move on to another example. This is something that I stumble on from time to time, and that's a topic of dealing with XML. I've had many times where I've needed to quickly manipulate an XML file, and you know that that's just not fun without opening up some bloated tools or getting deep into a programming language to help you out. In fact, recently I remember an example where a customer of mine had an issue, and we had an XML file that contained information about a process. And we had the opportunity to open that XML file up and dig into it and see if we could find some duplicate nodes that would indicate the problem that we were having. So what I needed to do was take that XML file and find duplicate nodes inside of it. And I didn't want to spend a ton of time on this. Instead, I thought to myself, I should be able to find some command or program on the command line that should allow me to manipulate this XML file, perhaps with an XSLT. We're not going to do that in this example. I want to keep it a little bit more simple, but we are in this example going to download an XML file. And when we download it, we'll see that the XML file is not formatted in a way that's very humanly readable. So this is a data set here on data.gov called the MyPyramid food raw data. And if you scroll down here, this is public access, so you can use this. In fact, data.gov is a great source of free data sets. Anyways, if we download this XML file, and then we open the zip file up, and then open up one of the XML files inside, you'll see what I'm talking about. One big blob of XML, and if you scroll all the way down to the bottom, you'll see it's all pretty much on the second line of this file. If we wanted to just get an idea of what this file contains and what the structure looks like, it'd be nice if we could clean this up and pretty it up. Now, we can find tools like that plug into tools like Sublime that I'm using to look at this file right now. In fact, there's probably a pretty print. Maybe not. Maybe I'd have to go find a package for it. So I'd probably have to go find a package for that. But we could probably find that inside of our tools, and we could do that. But what if we could just do that from the command line? What if we had a command that we could run called pretty XML, something simple where we could clean this up, and then we could look at it and understand what's involved in the structures inside of this data set. Turns out working with XML, well, that's one of those things where languages like JavaScript and languages we're using on server-side code and client-side code probably already has to deal with a lot of XML, so we're probably used to the libraries and APIs that we could use to be manipulating XML versus trying to look up some obscure command that can run in a regular terminal, a command that there's no way it's going to be cross-platform, and then we're probably going to pull our hair out for an hour trying to find something. Instead, we process XML all the time with programs, especially JavaScript. Servers return back XML all the time. So we're already used to doing this, so this is a great example where JavaScript has libraries and APIs that you're probably already really familiar with, and it'll take you almost no time to do it with JavaScript, whereas it might take several hours in a terminal. So let's take this food display table and clean it up. Now, in the process of doing this, we'll need to read in the contents of this file, which means the very first thing we'll turn to is looking at the path module that will help us build a path to access this file. First thing first, let's create a new file to work with to pretty up this XML. So we can go over and create a new file in whatever IDE you're using. Let's call this pretty XML, as I was referring to, a command we might like to have available at the command line. And just to clean things up, I'm going to get rid of some of these blog posts. So it would be nice if we had a little script that would take an XML file and clean it up. Before we rush into that, though, and make it abstract and reusable, let's first just use this script as an opportunity to explore how we can path to files within Node.js and access that file that we just downloaded. Now, over in the terminal, if I use pwd to print the working directory, you can see I'm in this code/JSShell folder, and inside of here is our pretty XML.js. This is obviously not where we downloaded the file. We downloaded the file, and I'll ls this location, in our home directory, which we can refer to with the ~/downloads. And there you go. You can see the myfoodpedia data folder. And if I navigate into that, we can list the contents there and see one of the food display table.xml files. Now, we could go grab this file right now and move it over to our JSShell folder, but that's no fun. Instead, let's use the path API to path to this and open it up right where it's at, where we downloaded it. This will give us an opportunity to look at how we can path to files in Node.js. So inside of our pretty XML script, the first thing we want to do is find the location of the file we downloaded. So let's create a variable called XML file. Now, if I go back to the terminal, I can copy the folder where that exists and come back over, and I'm going to add a comment and paste that in. And then the name was somewhat long, so I'm going to copy that as well, just so I don't make a typo. So that's where that file is at. So we could create a string variable that holds that location. Now, the first thing that would be nice to do is take this file and just see if it exists before we try and open it up. We can use that same function we used before, fs.existSync, pass the path to the XML file, and then we can exit if something goes wrong. We could also be kind to our users and print out that the file doesn't exist. Now to use fs, again, we need to bring in the module, do that with the require fs statement. All right, now we should be able to run our program. Let's go back to the terminal and type in node and then Print XML. And that returns without any output. That's because I should have inverted the condition here and said the file doesn't exist. If the file does exist, it hits my warning block, which doesn't make sense. So the file doesn't exist, that's when we want to warn the user. And that's because the file doesn't exist. Oh, and exit is not defined. This is really my lucky day. So process.exit. Run that again. Okay, so we're getting an error, the file doesn't exist, and I knew that was going to happen. I wanted to show that to you. And that's because Node.js isn't set up to understand the tilde in its APIs that work with files and paths. Now, there are a couple of ways to work around this, one of which is to access the path module and build up the location of this file a different way instead of using the tilde. So we can grab the path module, and then let's go take a look at the API for this. So if you come back to the Node.js documentation, take a look at the path module, you can see we have various different functions here. Now, one we could use is this join one. And I know that we can use that because what we could do is take our current location in our program and path relative to wherever this file is at versus where we're at now. How in the world are we going to do that? Let's hop back to the terminal really quick and open up the Node REPL. It's a great way to play around with the various different objects in our environment. For example, we can type in process.env. And in here, you'll see pwd is an environment variable with the current working directory. You can see its users Wes, code, JS shell. So what we could do then is go over to WebStorm, and using path, we can call path's join function. We can pass as process.env, and then .pwd capitalized. That'll be the first part of our path. That's where we're at right now. Now what we need to do is go up 2 directories into our home folder, and then the download folder will be right next to that. So just show you where that's at. Let's open up the Node REPL and do this from here, and then we can come paste this into WebStorm. It's always nice to use the REPL to try out some code and then take it over to your script. So let's bring in the path module. Now the path module is available as a part of Node.js, so you don't need to use npm to pull it down. It's a built-in module, unlike Moment, which was an external third-party module. Okay, so we have path, and we have process.env and then .pwd. What we can do then is path.join, pass in the process environment variable for the current working directory, and we'd like to go up 2 directories and see what that looks like. Looks much better. In fact, in doing this, if you're looking ahead, you might notice another environment variable we could use instead. Do you see this home environment variable? Yeah, that's actually one we could use instead of pathing from where we're at. Let's go back and wipe out what we have here and put in home instead, so we don't need the extra ... slashes to confuse us. So we know there's a downloads folder inside of our home directory. If we had messed that up, let's see what happens. Nothing happens, and that's just because this path module simply helps us build up paths. They don't have to exist. That's where you could use the exists sync on the fs module to see if a file exists. So keep in mind, this is just a path builder. It's really pretty neat. Always use this instead of trying to build paths by hand. There's no reason to concatenate strings and get into that nightmare of knowing if you need an extra slash or not. Okay, so let's go to the one with downloads as our download folder. And then we can use this and take this over to our program. We can replace what we started to build, and then we can grab the rest of the location of this XML file. And I can yank just that out. Show you one last thing about the join path builder. You can paste in as many parts of a path that you'd like to join together, and they'll all be joined together, in this case as if they're separate directories. The path builder will take care of the slashes for you. Just to keep our sanity, let's go ahead and log out what we've built up here. This will be our XML file. So we'll create that variable. We'll log that out, and then we'll see if it exists or not. Kill our Node REPL, and let's run our Print XML. All right, our path prints out with no warning message, which means that the file must exist. Next, I want to show you one other alternative you can use if you'd like to use the tilde instead of referring to the home environment variable. Before we take a look at opening up this file, I want to show you, if you would like, a way you can use tilde expansion. It's not built into the Node.js APIs, but guess what? There's a package available for it. First, I've modified the script here. I commented out what we just built in the last video, where we used the home environment variable to help us out. And I've gone back to using a tilde instead to refer to the home directory. Out on npmjs.com, you can come and search for tilde and just put in tilde and search for it, because I want to show you something to watch out for. There are two different packages that come up. First is the expand tilde, and this is the one we want to use, but be careful, there's also one called tilde-expansion, which comes up when you're in the autocomplete. Don't use that package, and I'll show you why. If you take a look at it, this package takes a path and then a callback to expand, and I don't know why in the world people think it would be necessary to have a callback here. Tilde expansion should be a synchronous task. Perhaps they're validating the path or something, but that's ridiculous. And as you can see, there aren't many people that are using this package. Versus expand tilde, and you'll know this is the right one because there are thousands of people that have used it in the last week. By the way, package popularity can be a decent way to get an understanding if people are using a package, which might be a factor in considering whether or not you want to take advantage of the package. So to use this, we can copy the example provided, come back to WebStorm, paste it in, and then let's grab the function call, and let's just wrap our XML file with a call to expand tilde. Save that, and then let's go to the command line and try this puppy out. And of course, it would help if I installed the package. So we need to do npm install and expand-tilde. Clear the screen here. Let's run our script again, and there we go. So you can use tilde expansion if you'd like. If you import this package, it can help you out. Now, I would be careful to point out that when you start pulling third-party packages, they're great to use. In the case of tilde expansion with paths, it's very possible that there may be some edge cases that don't quite work as you would expect on different operating systems. Just watch out for that. Don't blanket assume that people have made these independent packages cross-platform, especially when it gets into file pathing. There's just no way you usually get cross-platform file pathing. Though I will point out, aside from tilde expansion, the path module is wonderful. And you should stick with it if you just want to know that things will be okay with path. And you should just stick with it if you want to know that path building will be okay. And in that case, use the home environment variable. I'm going to hop over to my Windows machine here. And then I'm going to run this expand tilde function and show you that this works on a Windows device as well. And I wanted to point that out because I just realized that process.env.home is undefined on my Windows machine. It's home path instead. So that'd be something you need to watch out for, and this expand tilde package takes care of that under the hood for you. So let's stick with the tilde expanded version because that seems to be a bit more cross-platform, but I did want you to have a chance to see that path module in action. Again, as long as you're not dealing with tilde expansion, it's a great API to work with. Back to the task at hand, we'd like to open up this XML file and pretty it up a bit. So the next step is reading the contents of that file and pulling that into memory so we can manipulate it. Back in the documentation for the file system API in Node.js, like write file that we used before, there's read file. And again, keep track of the fact that there's a synchronous version of this, unless of course you want to make your code a little bit more obtuse and difficult to understand, stick with the synchronous version of these APIs. Looking at the documentation for this, at least looking at the asynchronous version, there's some information here. We can see that we can specify some options, and the second option is to specify the encoding of the file. If you don't specify an encoding, you'll get a raw buffer instead, so we'll need to include the encoding as the option. So let's grab this line of code, go over to our Print XML script, and as long as the file exists, we'll go ahead and read the contents. We'll say XML equals, and then we'll read in the file, except instead of etc password, we'll use our XML file. And of course, we want the synchronous version of this API. If that works, we should go ahead and print out the information just to see what we've got. So let's go ahead and console log the file, in essence, replicating the cat command here. Go back to the terminal, run our script, and there we go. We've got the XML coming out. So we've successfully read in the file. One thing worth pointing out while we've more or less replicated the cat command at this point is that we can pipe the output of our program here, our XML file, to any other command at the command line. For example, the cat command, if I picked one of my files in this directory, the Print XML, can pipe it to the less command, and that's not too exciting because the file's not very long. But I get this interactive session to scroll gradually through a file, especially if it's a really long file. Maybe I should refer specifically to the file we downloaded. That's a big file. So if I cat this normally, it does like we did with our program. We can pipe that to less though, and now we can scroll through the output here. I can even scroll with my trackpad. When I'm done, I can just hit Q to quit out of that. We can do the exact same thing with our program. Run our node pretty XML and pipe that puppy to less as well. And now we have the same scrolling if we were using any other command that's passed to less. This is the beauty of using JavaScript as a shell scripting language. You can take the scripts you've created and plug them right into traditional shell scripts. So you could mix and match as best suits you for whatever the task at hand is. Perhaps part of the shell script is best written in JavaScript, and the other part perhaps is best written in Bash or PowerShell or whatever it might be. You can mix and match. Now the fun part, let's clean up and pretty up this XML. If we go to npmjs.org and we search in here for pretty XML, I'm sure we can find something. In fact, there are probably a couple of different packages that came up. What I found that worked best was a package called pretty-data. So a little bit misleading because there was that other pretty-xml, but this pretty-data, well, I picked it because it's pretty popular and it seemed to work well when I was preparing this demonstration. So again, all we have to do to use this code, come over to the terminal, run npm install, and paste in pretty-data, the package we want to install. We can come over to WebStorm then, and then we can import this. Call it pretty-data, whatever you would like. And then if we want to figure out how to use this, we could click on the repository here, but I want to show you one other way to get to the repository, which usually has a little bit better documentation. From npm at the command line, you can type in npm and then the subcommand repo, and then you can specify the package, and you can jump then right to the GitHub repository for that package, or wherever the repository is located at. Now I'm looking here for some examples, and here we go. Okay, so we have this pretty data API, and there's an XML function that we can call, passing data, which I assume is XML. And the result we should get back is hopefully pretty XML. .xml, that's all I have to remember. Hopefully I can remember that when we get over here. Okay, so we have our XML that's unpretty, so let's make a pretty XML. We should be able to call pretty data.xml, pass in the raw XML, and then let's grab the console log, and that's what we'll output instead. Okay, save that file. Now everything should be pretty. Let's see what happens. Take off piping to less and just output the file. That's interesting. Not very well documented in terms of being at the top of the example, but that's okay. Down here you can see the PD function is available as a property of the module that we import. Go over to WebStorm, and we can call .pd to access the pretty data function. Now if we go back to the command line, pretty things up. Hey, that looks pretty good. Scroll up here. Actually, let's pipe this to less now. Now you can see how we can scroll through with less, and when the data is in a manageable format to read, a pretty format here, then I think you can understand more what it's like to use less to scroll through this data. All right, so we have something we can somewhat understand now. And the best part is we're pretty close to making a reusable script that we could save and keep on our machine, so whenever we want to pretty up some XML, we could refer back to it. In fact, we could quit out of less here, clear the screen, and let's take our pretty output and let's just redirect it out to a file called pretty.xml. We list the contents of our directory here. We have our pretty.xml, and we could run the open command to open up that pretty XML file. And I guess one little problem, we're leaving that console output there with the path to our file. We'll get rid of that. So now we've saved this file just by virtue of redirecting the output. That's what I'm talking about with mixing and matching. We've got this script that pretties up the XML and just spits it out to the standard output, and we can pipe that right into a file. Now we have this to refer back to. So as you can see, we're starting to form the basis of a pretty neat command here. A little bit of verbosity and needing to specify node. We'll take a look at that later in the course. But we pretty much have this pretty XML command, and then we specify the output file. The only other thing I could think of adding would be an input parameter so we could specify any XML file here. Let's take a look at that next. It'd be nice to be able to do something like the following. It'd be nice to more or less just call our pretty XML command, And later on, we'll look at how we can simplify this part, but let's pretend that would just be a nice pretty XML, just this pretty XML node.javascript and no node. It'd be nice then to pass an argument here for the file. So let's say we want to go to our downloads folder, and inside of our downloads folder, let's say we've got that myfoodpedia data folder, and inside of there are actually 3 XML files. What if we'd like to format the second one, the needing condiments table? Be nice if we could pass that as an argument and then pipe the output to, well, let's just say fnct.xml. Of course, at this point, that's not what happens because we've hard-coded the file we'd like to use. However, we can get access to this last argument we passed. If we go over to WebStorm, and wherever you'd like to do this at, the process global object can give you access to the arguments. So we can say var args equals and then process.argv. Let's go ahead and just log those out. And then let's exit with a 0 exit code so that we terminate our process without continuing on. That's one other thing that the exit function does, and oh, that's also on process.exit. So let's exit our program before continuing on. All we'll do is print out the arguments. Execute our program again, and of course it doesn't help that we're piping the output to that XML file. All right, so here are the arguments. The first argument is the path to node. That makes sense, that's the command we ran. The second argument is the absolute path to the script that's being run, and the third is the absolute path to the XML file that we'd like to load. So one thing bash is doing here when it's executing this command is it's expanding out all of these arguments to absolute paths. We really don't have to worry about tilde expansion because that'll be done by bash now. See, that's that great part of mixing and matching and combining all of these things to make the best of both worlds. What that means then is we can access this last argument in our shell script instead of needing to hard code it. We don't even need to worry about tilde expansion anymore. Let's go ahead and comment out this line. And what we would like to do, get rid of having arguments, get rid of the console log. And then our XML file should be in the args array at position 2. It's the third element in that array. You can inline this variable, clean this up a bit. So we've got our XML file. We'll get rid of the old version of it. We don't need that anymore, which means that we really don't need access to the path and expand tilde modules. Get rid of those. Okay, so we've got our XML file. It'd be good to check to make sure it exists and print out an error if it doesn't and exit with a non-zero exit code. And then if it does exist, we can go ahead and open up and read the file, pretty it up, and send it on out to the standard output. Go back to the terminal, clear out the screen here, and let's hit up arrow a few times. Let's run it on this other needing condiments table. And there we go. We've got cleaned up XML for the condiments. Hit the up arrow. There's the display table. And we've got the different XML there prettied up as well. So we can now reuse this command. It's becoming a tool we could put in our tool belt when working from the terminal. And remember, we can now redirect these, so we can permanently save a copy of our prettied up XML files. List the contents here. There's our 2 files. So the nice thing is, if we had a program that, say, couldn't work with XML globbed together like it was and it needed to be prettied up to work with it, we could now feed those into that program. Or if we simply wanted to read these as humans, we could read these as humans now. We have reusable scripts here to pretty up XML. As we wrap up this chapter of the course, I just want to point out that the final result of our generating blog post in Pretty XML will be available in the working files. So if you'd like to follow along a bit easier, going forward in the rest of this course, just look in the working files if you get stuck trying to follow along, and also you can refer back to these now. In the next chapter, we're going to take a look at how we can use ShellJS, which is a package available via npm.js. ShellJS adds a bunch of convenience functions and methods to do things you typically do at the shell from inside of your JavaScript shell scripts to simplify things rather drastically. So we'll take a look at that next. In the meantime, though, if you'd like a challenge, see if you can write the word count command, a command that takes in a file, loads the contents, counts the number of words in that file, and then spits out the number. For example, if I come to the terminal here and type in wc for word count and pass in our pretty XML, you can see there are 313 words. See if you can replicate the output of this command, but do it using JavaScript. So create a new word count command, much like we did with this pretty XML script. In the last chapter, we related various shell programming concepts to the similar constructs in Node.js. For example, reading and writing to files, working with environment variables, adding arguments to our shell scripts, returning exit codes, logging to standard input and output, piping the output of our program to other commands, and we took a look at file pathing. In this chapter, we'll continue to explore further shell concepts, while at the same time taking a look at a library called ShellJS, which can simplify or make more familiar writing shell scripts in JavaScript. ShellJS is a library that provides many different functions that resemble functions you would normally call from the command line. For example, cd for changing into a directory, pwd for printing the working directory, ls for listing files, and so forth. This library gives you a helpful set of aliases that can simplify the process of doing things that you'd normally do in the process of writing a shell script. And of course, you can use the Node.js concepts we've been looking at, but sometimes it'll just be easier because your memory will recollect these concepts perhaps a bit faster if you're familiar with writing shell scripts already, and perhaps you'd like to use these when writing shell scripts just to say similar to what you would be writing at the command line. The best way to understand this is to first open up the REPL and work with this ShellJS library. To do that, we'll need to install it first, though. So we can use npm install in ShellJS to install the ShellJS library into our Node modules folder locally. Then we can spin up the Node REPL. And then the first thing we'll want to do is import the ShellJS library. Now, normally when we've been importing libraries before, we've been capturing variables that represent the API of the module exported by that third-party dependency. And that's fine to do, so we can import ShellJS, and then we can access some of these helper functions, for example, to print the working directory. But that's somewhat verbose. There's a second way you can import the functions that are available in ShellJS and put them into the global scope to make things more concise. Instead of just requiring ShellJS, you can require specifically the global module within the ShellJS package. You don't need to capture a variable for this, because this global module will add these aliases that are available in ShellJS to the global scope. Now we can simply type pwd to print the working directory, or ls to list the contents of the working directory. So now here with the Node.js REPL and ShellJS, we have access to a shell in a way that's a JavaScript shell that has many of the same commands we would use in, say, a bash shell or a Windows command prompt. For example, cd is another function we have access to, and I've created an images folder for this chapter that has some images that we'll be working with. So we could cd into that directory. We could print the working directory. Oops, that's a function. We'll need to execute it. And you can see we're now inside of the images folder. So when we ls the contents of this folder, we can now list the images that are available. And of course, we're getting an array back, a JavaScript array, an array that we can then perform processing upon. And this introduces the example that we'll be working with in this chapter, which is taking a set of images and processing them to produce thumbnails. Let's say you went out on a photo shoot and you have several hundred images and you'd like to resize them so that you can put them up on your website in a size that won't overwhelm people that download the images. Say, for example, these images are several megabytes in size. You might want to shrink them down so they're only a couple hundred kilobytes and easier to access. And that's what we'll take a look at in this chapter, is creating a thumbnail shell script while taking advantage of the features that ShellJS provides. Let's get started on our thumbnail processing script. Let's close out of the Node REPL here. Now we already have ShellJS installed locally, so we can hop over to our editor and let's create a new script. And we'll call this thumbnails. And then inside of here, just like at the Node REPL, we can import or require the ShellJS/global module. This will import all these helper functions into the global scope. So right from here, we could ls the contents of a directory. Now, keep in mind that we're not in the Node REPL, so we'll need to capture the result of that, and that's going to be an array of files. Let's assume eventually these will be our images, so we'll capture those into an images array. Now, we're not quite in the right directory yet, but that's okay. The next thing we can do then is echo out the contents of that images array. Now, keep in mind that echo is simply an alias to console.log. And honestly, if you like console.log, go ahead and keep using it. If, however, you like echo because it's a little simpler to type out, well, then that's fine too. I'd also like to point out that ls is a bit easier way to work with an fs function we haven't looked at yet, but one you could access instead, which is fs.readdirsync. Let's take a look at that in the API. Again, there are two versions of this, readdir and readdir sync. You'd want to use the readdir sync if you access the FS module instead of using ls. You provide a path to this, and then you get back an array of file names just like we're getting back here with ls. So again, you could go with either of these options. I personally like ls here. I think it's a little more explicit just with my general background of using ls at the command line. And it's obviously easier to type out. Okay, so we're listing the contents of our directory into an images array, and then we're printing that out to the screen. Let's go and run this script really quickly and just see what it does. As you can see, we're printing the contents of the folder we're in right now where we're running the script at, which will depend upon wherever we're executing the script from. For example, if I change up a directory and I call the script again, I'll need to path into the directory where the code is at, JS shell, in my case, /thumbnails.js. If I run that script, now I'm listing the contents of the directory that I'm executing from, which is one directory above, so I no longer see the same files. Just like if we were working from the command line and we had called ls from the parent directory. Later on, we'll look at adding an argument to specify what directory we'd like to look in, but for now, let's go back into the folder where our code is at, and let's run our script again. Okay, so we have this set of files and folders inside of the current directory. Now everything should look familiar except this images folder. If I cd into the images folder and list the contents here, you'll see there are some images inside. I'm going to go back up a directory though, and then I'll go back over to my script, and now I'm going to list out the contents of that images folder. Let's clear the screen here and run our script again. Okay, so now that I'm listing the contents of the images folder, you can see we get images back. And this ls alias works just like the command line. For example, if I want to list the contents of the images folder, I can call ls here, and you can see the output looks very much the same between running ls with ShellJS inside of Node.js versus running ls here inside of bash. Just to be safe, we don't want to list out files that are not image files. So if I created a file in the images folder that's just a text file, and if I list the contents, you can see now we include that text file, which we wouldn't want to include and process as an image. So instead, we could just list JPEG files. And now we don't see the test.txt. If I go back over to my script, and I do the same thing, asterisk dot and capital JPG, run my script again, you'll see, much like ls, that the full path to the file is now available. Whereas before, when we ran our script, it mirrored ls and only showing us the files that are inside of that folder. But now that we're using a wildcard, we're getting the full path at the command line with bash and with our call to ls from system.js. So it's nice that ShellJS mirrors ls's behavior in bash. And of course, you can see here, we're not including that text file either. Now in this example, I've created JPEG images. You can use whatever images you'd like to follow along with. Just keep in mind if you use another image type, you'll need to search for that instead of JPEG. So now that our script can list the contents of our images directory, and we can filter down to just the images we'd like to access and convert to thumbnails, we can now go about the process of making those thumbnails. And the first thing that comes to my mind is I'd like to stick those thumbnails somewhere else. I don't want to overwrite these files. So naturally, I'm inclined to want to create a thumbs directory inside of this images folder. And inside of that thumbs directory, I'd like to save all the images in their resized format. And this affords a great opportunity to talk about working with directories inside of a shell script and to take a look at some of the helpers we have available with ShellJS. Now, we've already seen cd and pwd. We're now going to take a look at rm and mkdir. Now, rm removes files, could be files or directories, and mkdir will make a directory. These two functions are somewhat universal across different command line interfaces on both Windows and Unix and Mac OS, hence why ShellJS provides these. So why are we going to use both of these? Well, in my mind, when I create the thumbnails, I'd first like to blow away any thumbnails that might already exist, just to wipe those out. And to do that, I'll want to call rm and remove the thumbs directory, just in case it exists already. That way I don't have to worry about going through the contents of that thumbs directory and removing what I'll be regenerating. And then, once that's done, I'd like to make the thumbs directory. So I'll more or less wipe out the directory and then recreate it. Now you could choose whatever you'd like to do, but this is a simple strategy to make sure that we always start with a clean working state. Now if you've worked with the rf command at the command line, when there are files inside of a directory, this isn't going to work. We'll also need to specify the flags -rf to force the recursive removal of everything inside of that thumbs directory. If you're curious about the API for ShellJS, just hop back to the ShellJS documentation, which, by the way, if you want to get to this, you can Google for ShellJS, go to the GitHub site, you'll see a link to shelljs.org. And shelljs.org redirects to this document up.com/shelljs. Inside of here, then, look for RM, and you'll find information about the RM function. Here's the -F for forcing the removal of files, and the -R for recursive, just like you'd run from the command line. There are also some examples provided here, so this is a great resource to refer to. Okay, so we'll wipe out the folder if it already exists, and the nice thing about RM from the command line is it doesn't matter if the folder doesn't exist, it'll just move on without doing anything. However, if it does exist, it'll wipe it out, and then mkdir for making a directory will recreate it. Now, the one thing I've noticed is right now I'm referring to thumbs, and we know we're starting in a directory that's one folder up from our images folder, so this really should be images/thumbs. Now, there are a couple of ways you could approach dealing with this. First, you could cd into the images folder, but in this case, I don't want to change the path and possibly confuse myself. I'd like to just operate from the same location I started from, in which case I can just prefix this with images/thumbs. Okay, so let's go over the command line and see this in action. First, let's list the contents of that images folder again. You can see there's no thumbs folder. We run our script now and list the contents of the images folder. You can now see a new thumbs folder. Of course, there's nothing inside of that at this point. If we put a file into that images/thumbs folder, so you can see the A file there when I listed the contents, when we run our script again and list the contents of the thumbs folder, you'll see it's wiped out. So we now have a known working state that's empty to write out our new image files once we convert them to thumbnails. Before we move on, I want to show you the equivalent of these commands without ShellJS. First, mkdir is available from the FS API as fs.mkdir, and then of course you'll want to use the synchronous version of that. And this more or less works the same as the ShellJS version of this function, except one nice thing about ShellJS is that it takes the -p flag to create parent directories. So if a parent directory didn't exist, ShellJS will go ahead and create those as well. That can be really helpful if you're nesting something into a directory structure that may not exist yet, just to go ahead and create that, just like you'd have available from the command line with mkdir-p. So that's one advantage of using this over the fs.mkdir sync method from the Node.js APIs. And then rm to remove a directory is accessible via the FS API's rmdir, and again, use a synchronous version of that. And of course, this rmdir is more specific than ShellJS's rm function, because the rm function can remove folders and files, whereas rmdir is meant just for directories. Okay, so at this point, we have a list of our images. We've created a directory to convert them into thumbnails. Now we should go about converting them to thumbnails. And to do that, I've picked a package from npmjs.com that you can access by searching for lwIP, lwIP, we'll call it. It's a lightweight image processor for Node.js. And one of the nice things is it doesn't depend upon other software being installed on your computer to perform the transformations. Though I will say the installation process for it takes a little bit of time. Might take about a minute for all the various different code modules behind it to compile. Whereas I'm going to clear my screen here, and let's go ahead and install this lwIP package. Again, don't be alarmed that this takes a few seconds to compile the C++ modules used by this library. Okay, now that we have this installed, we can take a look at how to use it. If you go back to the documentation for this library, you'll see there are many different transformations we can perform upon images. The one I'll be taking a look at is this contain transformation. And I've pre-picked this in advance because what this allows us to do is specify a width and a height for our images. It will create a canvas, and the image will be fit onto this canvas, and then anywhere that the image doesn't overlap with will be replaced by whatever color we pass. And we'll be passing white. So what we'll do is shrink down our images to a square size, just to keep this process simple, and then we'll pad the square with white. Before we do this, though, let me show you the images I created. Here's the images folder that we've been working with. I just took a few images to work with. Nothing exciting. You can pull down whatever images you'd like from the internet or use some images on your computer. We've got 4 different images here, though, and they're rather large images, about 1.5 megabytes. I took these with my iPhone. So we'll want to scale these down to a more reasonable resolution. And we'll do that with the contain function inside of this lwIP package. Okay, so we've installed the lwIP package. Let's go ahead and import it. And then down below our calls to prepare our environment to convert images to thumbnails, we can take our images, and then for each image, we can execute a function that performs a conversion. So each loop of this for each statement will get an image file, and we'll open up a function to process each of the images. And in here is where we can call lwIP.open, and then you can specify the image file. And then there are options for flags and modes, which we don't have to provide. Instead, we can just pass a callback. By the way, this IntelliSense that we're getting as we're typing here to help us with the function call, this is one of the beauties of working with JavaScript. Many editors can help you out. Even though JavaScript is a very loosely typed language, editors can still help you figure out what functions are available and tell you what parameters are necessary. This can really expedite the shell scripting process. Okay, so the callback is what we need to specify for once the image is open. So again, we'll open up a function here, and we'll do that by accepting the image parameter into a new function. And I'm using functions defined as anonymous functions using the new fat arrow syntax in ES6 or ES 2015. A little more compact or concise to write this. You could type out function if you want, but I like this new syntax. So this would work as well. And of course, I'm missing one more parameter to this function after the call to open, and that's that there could be an error specified with the callback, keeping with the Node.js convention to specify the error as the first parameter to a callback and then any subsequent parameters thereafter. Now at this point, we have an opened up image with a lightweight image processor. We could do simple things like echo out the image's width, and perhaps we could clean this up a little bit. And let's go ahead and print out the height as well. It might also help to echo out the image that we're working with. So as we loop through each of the images, the image file will tell us which image we're working with. So we'll echo that out, and then we'll echo out the dimensions of the image. Okay, and then we can hop back over to the command line. Let's go ahead and run our script. And there you go. You can see each of the images, and you can see the width and the height. And they're all the same because I use my iPhone, so they're all the same dimensions. But what we'd like to do is scale down these images to a 200 by 200 thumbnail. To convert the images, let's first produce a path where they'll finally reside. So the thumb file, in keeping with my name here for image file as the input, thumb file for the output, will equal, and then I need to put this into this images/thumbs folder. Now I've already hard-coded this a few times. What I'd like to do is perhaps reuse this. Maybe we'll create a thumbs directory variable. And I'd like to put this thumb file into that thumb directory. And I could just start concatenating on a path on the end here, but that's not pretty. Let's use the path module in Node.js. And we'll use path.join. We'll pass a thumb directory. And then we need to specify the file name for the thumb file that we're writing out to. We can use another function that's available with the path module to get just the file name. Right now, image file contains the entire path of the image. If I go over to the terminal here, you can see images/ and then the file name. I just want to remove img1694.jpg. I don't want the images prefix on there. We're changing the folder on that. To get the file name, we can use the base name function on the path module. So base name, and then we pass the path for the image file. And just to help you out, let's go ahead and print that out. And then we'll use that to concatenate onto the end of our thumbs directory to produce the thumb file path. That's a lot of pathing going on, so let's echo that out as well and take a look at the result. Let's go over to the command line and run our script again. Okay, so you've seen here for each of these images, here's the source file, here's the base name, which is just the file name with the extension, and then here's the destination file, the thumb file. So it'll be an images thumbs and then our image with the same name. Everything looks okay with our pathing. Join me in the next movie where we will finish out converting our images. Okay, let's use the lwIP package now to convert our thumbnail. Let's get rid of some of the output here that we don't need. Let's get rid of all the echoes except the last one for the thumb file. What we'd like to do now with each image is use lwIP to convert it. And we can do that by first calling batch from the lwIP API. This will start up a batch set of conversions that we can perform on this image. This is just a simple API to work with where we can chain together a series of calls to manipulate an image and ultimately to save it. Now all we're going to do is call contain, which is that function we looked at in the API, and we'll specify the width, the height, and the color. So we're going to contain the image to a 200 by 200 canvas, and we'll use white as the color to pad the image. That's the first operation. Now, we could continue to perform other operations, like we could rotate the image. But I don't want to do that at this point in time. The reason I called batch was now I can use the write file, and I'll show you where that's at in the documentation. And that takes a path and then some options. Now, in the interest of saving time, I'm just going to paste how we'll use this function in here. We'll call write file. We're only passing the thumb file, the location we're writing to, and then we're passing the callback, so we're not specifying any options. If there's an error, we'll log that with console.error and bail out of this function. Or we'll echo that we completed the conversion of our thumb file, which means we can get rid of this first call to echo out the name of our thumb file. And I just noticed I made one mistake. I see both of our parameters here to the callback for open are unused. We should be using the image parameter. It's image.batch, it's not lwIP.batch, and that's why I wasn't getting much help. Now you can see I'm getting some help here. Okay, so we take our image, we perform a batch set of operations, just two operations, contain and write file. Let's hop over to the terminal, and let's run our conversion. And you can see in the output that each of our thumbs have been converted. Now, of course, you probably would like to see the result of that operation. We'll take a look at that in the next clip when we take a look at ShellJS's exec function. All right, so we have our image conversion done. Now, we could just go look at these files in our file system and open them up, but that's no fun. I want to take the time to show you one last feature of ShellJS with this example, and that's the exec function. The exec function allows us with ShellJS to shell out, if you will, and execute commands that we might have executed from the command line. So for example, I could run open here in the command line and specify one of these thumbnails, and this will open up that thumbnail. Sometimes when you're writing a shell script, you'll want to shell out and use some command that's available on your system. And it's really easy to do that with ShellJS. There's an exec function that allows you to pass a string that will be executed as if you had called it from a terminal session. So I could pass open here, and then I could specify the name of the thumbnail file. So once the thumbnail is created, we'll go ahead and open it up then by shelling out and calling open from the bash shell here. It's important to point out that this might not be cross-platform compatible. Nonetheless, let's see what this looks like so you know what it's like to shell out and access a command that you'd normally use, which is another great way to integrate with existing programs from a JavaScript shell script. Let's clear the screen here. Let's execute our shell script again, convert the images again, and you'll notice they're opening up here as they complete. And we can see our converted images, including some of the padding we've added. And then if I open up the file system, you can see the originals, while over 1 megabyte, these thumbnails are only about 30K. Much, much better if we wanted to put these up on our website. And we don't have to go through the hassle of converting these all by hand or trying to find some pre-existing program that can do this for us. We now have this lightweight image processor that we can use from Node.js to perform batch operations on images. I'd like to hop back and point out one thing about the ls function. Just like at the command line, it can be unpredictable whether or not it includes the full file path or not. So if I ls the images directory, you'll see the file path is not included, whereas if I pass a wildcard and specify only JPEG files, you'll see the path is included. This could be problematic. Trying to keep that in mind, especially when you're programming and expecting to work with file paths that are somewhat predictable. A better alternative could be to use the find function provided by ShellJS, much like there's a find command you can use in some terminals. So instead of using ls to find our images, we could create our images by calling find, and then inside of the images folder we could find everything. Now before we filter down to just the images we'd like, I'm going to exit out here, quit the rest of the program, comment out our prior ls, and what I'd like to do is just print out the contents of the images array right here. So we'll exit out actually after we echo. So if I run our program now, you can see we get a bunch of information back that we don't care about. What we want are just our image files. But the nice thing is we have the full path. And then what I'd like to show you, since this is just a JavaScript array, is that we can use JavaScript functions like the array prototype filter function, which allows us to filter and remove items that we don't care about. In fact, the example out on ShellJS's documentation includes a reference to this. We can call the filter function and pass a regex to filter the file. So keep in mind, you're using JavaScript. You don't have to rely upon built-in functions and commands like ls working in a certain way to allow you to filter down what you want. You can always use what you're familiar with. In this case, you can use JavaScript regular expressions. So for each file or path is perhaps a better way to refer to it, we'd only like to include it if it matches a regular expression. Now, the example given with JavaScript is not right. We want JPG for image files. Now let me point out one last thing. Let's put lowercase JPG in here. I used uppercase before because ls was case sensitive. However, with the regex, we can put lowercase in. Let me show you this doesn't work first, though. Looks like I have a little mistake in the function here. Ah, yes, an extra semicolon we don't need. Let's run that again. So nothing is matching our regular expression, and that's because regexes are case sensitive unless you add the I on the end to be case insensitive. Now you can see we're matching our image files. So that's one extra helpful little bit about using a regex instead of relying upon wildcards in the ls function, is that it's a bit more predictable about how it will match. And you're likely to remember the rules for regexes more than the nuances of the ls command. In fact, this will help us if we wanted to match other file types as well. Say, for example, that txt was a file type for an image, which it's not, but we have a file out there that matches that. We could include either txt or JPG files. Of course, the test.txt comes back and that won't convert properly because that's not an image file, but if you had PNGs or GIFs, you could include those as well using a regex. So just keep in mind, you have JavaScript at your fingertips, and the filter function is a great way to go through an array of files and filter down what you need. There are a few other functions I'd like to point out in the context of the past examples we worked with in prior chapters. Before we do that, though, I want to point out the exit shortcut that's available via ShellJS. I've been using it without even telling you that that was provided by ShellJS. But yeah, when you imported the global functions for ShellJS, it includes an exit, so you don't have to type process.exit. So it's a bit more concise. If we go back over to our pretty XML, we had an exit here. We call process.exit. We could remove that if we import ShellJS into that script. So this is a bit more concise, and we can pass an exit code value to that as well. Let's take a look at a few other changes we could make with ShellJS to this script. If you are reading from the contents of a text file, ShellJS provides a cat function just like the cat command or function we've seen in Bash. The nice thing here is we don't need to specify the encoding, and it's a bit more concise than fs.readFileSync. So we can use that instead to read our XML file in our pretty XML script. Let's hop over to the command line and see this in action, though, just to make sure we didn't break anything. So we can call node and then pretty xml.js. And first, I won't specify an XML file to clean up, so we can see if that process.exit transformation works. When I run that, we get an error back. And I know that the exit code is non-zero because the shell prompt that I have here shows non-zero exit codes, and we can see the value is 1. Now, to test the cat function, I'll need to specify one of my XML files. And it looks like we're still reading everything okay. In addition to cat, let's go over to our generate blog post. Let's copy the global imports for ShellJS. When we're writing a file, there's a nice little succinct way to do this with ShellJS. We can take the contents of the file, and we can use that as a variable, and then call to on the contents of the file, which has to be a string. So we can call header to, and then specify the file name. This is a much more concise way of writing out a file. To test this, let's go back to the command line, type node, and then generate our blog post. And we're creating our blog post. You can see if we cat the contents of it, works just like we had before. So cat and the .to functions are easy ways to read in text files and write out text files. There's even a to end which will append onto the end of a file. There's another helpful shortcut from ShellJS. Instead of calling process.env, we can now just refer to env for the environment variables. It's up to you which you prefer. I honestly don't mind prefixing some of these calls to exit and env with process, but if you'd like something more concise, this might be helpful, especially if you have a lot of references to make to environment variables. This example of converting images to thumbnails is a great opportunity to talk about prompting the user for input. Now, this doesn't have anything to do with ShellJS. Nonetheless, it's a great time to talk about it. It's one more shell programming concept you should be familiar with, how to pull it off with Node.js. When we were removing the thumbs directory and then recreating it, it might be a good idea to ask the user if they'd like to just wipe out everything in this directory before we go about wiping it out. What we'd like to do is check if the directory exists. So we could use fs_exists_sync, like we've used in the past, and then we could specify the thumbs directory. And we could only remove it then if it exists. Now that's an optimization we don't need because RM doesn't care if the directory doesn't exist. Nonetheless, it should only be nested in that block of code. Now up at the top, we'll need to import the fs module to have access to exist sync. One note before I move on, you could have written this as if and then use the test function that's available from ShellJS. You could specify -d to see if a directory exists. But honestly, I don't like how this reads. This is a bit more obtuse and difficult to understand than fs.exists. Exists? What? The directory? Oh, okay, yeah, so this is checking if the directory exists. That makes sense. Whereas the other test function, unless you're familiar with test and writing bash scripts, you might not be familiar with that when first reading this script. So if the directory exists, then we would like to prompt the user. Now there are a number of ways we can do this. Node.js includes a readline module that can help you do this, but working with it is rather complicated. You have to create an interface, attach input and output, and then you can ask questions and receive answers in a callback. And I don't like this callback style. This would be like using the asynchronous functions to read a file or to write a file. It adds an unnecessary level of indirection in the code. Instead, what I prefer, if you look for readline sync, this is an npm package that contains a synchronous version of this readline functionality and a much more succinct version of it. We can use this simple import to this readline sync module. We can ask a question and synchronously get back the response. This will keep our code much more readable. Let's go ahead and install this package. Clear out the screen here. Let's go to our script and paste in the import of that module. And then down inside of our existence check, if the directory exists, we can ask the user a question. And then we can tell the user that the thumbs directory exists, ask them if they'd like to wipe it out and continue. Of course, a nice thing here, we get a synchronous response back. Now, asking a question will return back a string with the result of whatever the user types in. In this case, we don't want to do that. We really just want to know yes or no. So readline sync comes with a key in, yn for yes or no. True or false will be returned from this function. So we'll use that instead of question. And all we'll do here, if the response is not true, then we'll go ahead and exit out of our script. It's not really an unexpected exit, so we don't need a non-zero exit code, but it might be nice to tell the user that we didn't convert the thumbnails. Now, one last thing before we execute this. When we were working with the find function, I added an exit call up here. We'll remove that. Now let's go over to the command line and let's run our script again. You can see we're getting prompted that the images thumbs directory exists, and we're being asked if we'd like to wipe it out and continue. If I choose no, the script is aborted. If I run this again though, and choose yes with the Y key, the thumbnails are converted. So there will be times when you want to prompt your user for whether or not they'd like to continue on, especially in the case of removing the contents of a directory, which could be a very dangerous operation. Before we move on, I want to talk a bit about portability, which we maybe haven't touched on too much yet. And I want to give a little bit of help to Windows users. Please, everybody stick with me. I have a few things to point out about portability that everybody will want to hear. And then at the end, I'll talk to a few specific issues you may have with lwIP on Windows. First thing, I just noticed that when we changed to the find command, we were recursively looking through subdirectories. We wouldn't want to make thumbnails of our thumbnails. So I just wanted to point that out. If your example still has find in it, we can revert back to using ls. It's a bit more concise, and that'll take care of that problem. Now, when we rerun the program, we only pick up images right inside the root of our images folder. Okay, so we haven't taken this code and put it on any other computers yet, and I've been demonstrating here on a Mac thus far, so why don't I take this code, pick it up, and put it over on my Windows computer, and let's take a look at what things look like over on that Windows computer and make sure that everything still works. I am over here on my Windows computer, and I have the folder up here with the code samples we've been working on. Here's the thumbnail.js script. I'll open that up for you. You can see the change I just made to go back to using ls instead of find. So I have the code up, I have the images, but there's no thumbnails folder. I also have a command shell opened up to the location of this code. Now what I'd like to do is run our thumbnail script. However, when we run that, we can't find ShellJS, and that's because we don't have the npm packages installed. Now up to this point, we've been manually installing those packages, so we'd have to come to our Windows machine and manually install each of the packages we need. And that'd be tedious. Of course, if you've used Node.js before, you know you can keep track of the packages that you need for a project by creating a package.json file. We haven't done that thus far, so let's hop over and do that on our Mac. And then we can copy that package.json file over to our Windows machine. What we can do, right from the JS Shell project folder where we have our scripts at, right where the Node modules folder is at, we can run npm init. That'll initialize a package.json file. We'll be asked a few questions. I'll just stick with all the defaults. The nice thing here, the first time you run this, npm init will pick up any installed packages locally in that node modules folder and add them to the package.json file. So you can see lwIP, moment, expand tilde, readline sync, pretty data, and ShellJS, all the packages we've used thus far in this course. If everything looks okay, we can click OK. And if you notice, there will be a new package.json file created with the contents we just saw above. What we can do then is pick up this file and copy it over to our Windows computer. So I've copied that package.json folder over onto our Windows computer. Now I can just run npm install to install the dependencies onto my Windows machine. So this is one of the big benefits of working with Node.js is we can start to create our own package of scripts. And it's real easy for us to tag external dependencies in a package.json file and then automatically install those onto another computer, even another computer with a different operating system. Right now, lwIP is compiling the C++ modules, and everything's installed. Now, before I talk about lwIP on Windows, let's just run our script here so I can run the thumbnail script. Now, before I do that, I'll show you again, we don't have a thumbnails folder. Run our thumbnails shell script, and we have a thumbs folder. Inside of there, you can see the thumbnails. I hope this helps illustrate the portability we have now of our shell scripts. It's very easy to pick up our environment and drop it onto another computer. Now, one thing I want to point out, if you're on Windows and you want to use lwIP, you might run into trouble on certain versions of Windows. For example, I hit some issues with Windows 10. You can find any issues posted out in lwIP, and these might be fixed by the time you work through this course. But if you have any issues, I'd encourage you to take a look at the NodeJIP project, node-jip. You can find that out on github.com/nodejs/node-jip. Look at the installation section and look at the Windows section. You need to make sure, if you're using Windows 10 like I am, that you have the latest version of npm 3.3.6 or later, which is okay because we're using 3.3.12 in this course. Install Python, make sure it's in the path, and it needs to be version 2.7 of Python, not a version 3 of Python. Make sure you've got the C++ compiler that's available via Visual Studio Community Edition 2015. And then if you are using the 2015 edition, you'll need to set this environment variable if you run into issues. The issue I had was making sure I had Visual C++ installed as a part of Visual Studio Community 2015 edition. So sometimes there are third-party dependencies, especially when you're compiling C++ code. If you have trouble with Windows, follow these instructions and everything should be okay. Specifically, just make sure you have Python and Visual C++ installed. That will take care of most of the problems you'll have. In addition to what we looked at with ShellJS in this chapter, there are many other functions that are available that may be helpful. I don't want to take the time to show all of these. I think you get the point. I'd encourage you to explore the documentation and specifically look at some of the other available functions. For example, cp to copy a file, or if we scroll down here, grep. If you like grep, here's cross-platform access to grep and sed. So if you are familiar with using those from the command line to manipulate text, you can continue to use those. If you are changing directories and you'd like to keep track of where you're at as you move through different directories in your script, if that simplifies pathing to files, there's pushd and popd to help out with managing directories, to manage your directory stack, just like in a regular bash terminal. And then lastly, I'd like to point out which can be a great way to determine if a program exists. So for example, when we shelled out to the open command, we could use which to determine if we can do that. If we can't, you could print out a warning to the user that the script isn't compatible with their system. Another great use case for this, if you require to execute commands with git, perhaps you've written a shell script that interacts with git, well, you could use which and git to determine if git is available, and then abort the script if not. If you want a fun little challenge, modify the script that we wrote, use which before calling open, and if open is not available, print out an error message to the user. Next up, we're going to take a look at some libraries that can help you out parsing arguments that you pass to your shell scripts. In the last chapter, we saw how we could use ShellJS to map some of the shell programming concepts to Node.js in familiar terms with functions like cd and ls and pwd, mkdir, etc. We also built out this nice thumbnail processing script that can take a set of images and spit out thumbnails for them. One thing we didn't do, though, was accept any input. We hard-coded the path to the images folder, and we also hard-coded the size of the images to 200 by 200. It might be nice if we provided some arguments for this. It might be nice if we had a size argument, and it might be nice if we had a directory argument, an images directory. And it'd be nice to go through our code here and use these arguments that we could then, in a minute here, provide when we call our script. That way we could make our script a bit more reusable. At this point, we'd have to have a hard-coded images folder, which might not be so helpful. So we could use path.join here now, take in our images directory, reference the thumbs subfolder. So we'll always have a thumbs subfolder. Perhaps you could even make that as an argument, but let's not get carried away. Then we can scroll down here and use our size argument. And I think we had parameterized the rest of our variables nicely so that we only had a couple of places to update here to use whatever directory could be passed into our program. Now we know from the past, if we want to add arguments, they'll be available in process.argv, and 2 would be the first argument, and 3 would be the second argument. We could come up and assume that our images directory is the first argument, and the second one is our size. Maybe we'd even like to provide a default and coalesce with a default value of images for our directory, and a default value of 200 for the size. Okay, so we could add that now. Let's go run our program from the command line. Node thumbnails. Now we need to specify a folder and a size, but let's see what happens if we don't. We're getting a bit of trouble. I made a little bit of a mistake in specifying the ls command. Need to use backticks for the template literal. Run our script again. Okay, so we find all of our images. We're warned that there's a thumbs folder, so we can go ahead and say, no, we don't want to override that. Let's remove the thumbs folder, just so we know that we're recreating these. So I'll list the contents of the image directory, no thumbs folder. Okay, good to go. Let's run our script again. And this time, let's specify the directory, and let's specify the size of the image. Let's change it to 300, actually. And we're getting an error, unknown arguments configuration. And I can tell you that's happening because we are processing a string, and this function is expecting an integer. So what we could do is wrap our process.argv coalesce by 200 with parseInt. Wrap the whole thing with parseInt just to be safe. Now if we run our program again, yes, we'll go ahead and overwrite the directory. All right, we create our images, and we open up one of them. And you can see now it's a bit bigger image. But the true test is to take a look at the thumbnails and make sure they actually are bigger. Here we can see 300 by 300. So we have some arguments now to our thumbnail script, which allows us to change things like the name of the directory. So we could come in here and we could move the directory images, and we could name this maybe img instead of images. If we list the contents of our directory, we now have img, and if I list the contents of that, you can see we've moved everything into that folder. I'll remove the images and the thumbnails folder just to show you that we're regenerating this with a new path. Now we can call our script again. This time pass img for the directory and 200 for the image size. You can list the image directory. You can see the thumbs now. If you list the thumbs folder, you can see the images. If we open up that thumbs folder, there's our 200 by 200 image. So again, we have that img folder now. All right, so we now can pass arguments to our script. The thing is, it'd be nice perhaps to show some help if somebody runs the script without passing arguments. We probably also shouldn't have these defaults. It doesn't really make sense that we're working with an images folder. And who would know that? Or if we are going to use that as a default, that's something we should also include in the help documentation. And what if people want to mix and match these arguments and move them around? We don't want people to have to remember what order to pass. We don't even want to have to remember ourselves what order to pass. It'd be nice if we had some more formalized way of building arguments. And that's where a package called Commander comes into play. And this is an npm package. And as it turns out, there are tons and tons and tons of these packages. This seemed to be a pretty popular one. It's one I've used before. You could pick a different one if you'd like. But the gist of this is this package will help you programmatically build out a set of arguments to your program, and it'll help you generate some quick help for those arguments as well. It'll give you much more flexibility. Once you've built out the arguments, people could pass them in any order they want. You can specify required versus optional arguments. You can add flags versus arguments that take values. You can pretty much set up whatever you'd like in terms of arguments. As you can see here in this example, they've got 4 different arguments defined, and then Commander will also parse those arguments for you and return back parsed arguments you could then use throughout your program, which drastically simplifies your code to create and manipulate arguments. Imagine if you had to update the script we have here to be able to accept arguments in different orders and with different flags as optional or required and with defaults. This would get pretty ugly pretty fast. So we can import this Commander library, and it'll take care of all of this for us. That's what we're going to take a look at in this chapter, how we can take advantage of a programmatic API to build out arguments and create a much more robust script. First thing first, we need to install the Commander package. Now, one thing I want to point out, to get this Commander package to be listed in our package.json file, add the -- save flag. When you do this, the package.json file will now include Commander. So when you need to access this script on another computer, you can simply run npm install and you won't have to remember all the packages you need to install. Also, FYI, here are all the versions of these packages I'm using at the time of the recording. If you have any trouble with them, or if there are major changes to them, you can see what versions I'm using. Okay, with that installed, we can now start to build out a description of our arguments, and that's what we're really talking about here. We're talking about building out an object model that represents our arguments, and we do that with Commander. Now, for the sake of saving time, I'll just paste in the sample from the Commander site. The first thing we can do is specify a version for our program. So we could say this is version 1.0. This is for the help that will be generated automatically. Now we have two arguments at this point. One is a size, so how about S for size and size for the long name of that argument. And we'll simply say the image size to shrink to, both height and width. So we can provide a little bit of help to users if they forget or we forget what these arguments represent. Okay, and then next we have the directory of images. So how about D directory? And then we specify a little help for that as well. Now go ahead and get rid of the other two options there. That's all we need are two options. And then we simply call parse to parse the arguments passed to argv. Notice we're passing process.argv onto this object model we built of options. So we build up our options and then we parse the options right out of the input that came in to our program when we executed it. And then we need to replace calls to process.argv with program and then the long name of the argument. So program.directory for the images directory and program.size for the size. Now I'll leave these defined up at the top simply to decouple Commander from the rest of the program. So we'll still keep these globally defined variables global to our script. Now we need to do one more thing to specify that we're expecting options that have values instead of just flags. A flag is when there's no value associated with a particular option. We're just turning something on or off. But in our case, we're expecting inputs for the directory and for the size. So we need a number for the size. We need a value for the directory. So we need to come to our program definition for our arguments. We need to specify that we have values here. And in our case, these values are required. These aren't flags. So when we specify a size, we need to specify an integer. And since this is required, we use less than and greater than signs. Now you can put whatever text you'd like in between here. So I'll put integer. This will just come into the help for the user to help them know what type of information you're expecting in this input. And then for the directory, well, that's just a string. So we could type directory, or maybe string is better to connote that we want a directory string passed here. Actually, path is even better. Okay, so we take in a size and a directory argument, and those are both required. Now, if we wanted one of these to be optional, we could put brackets around it, but both of these are required, so we need to put the less than and greater than sign around them. With those defined, let's come back to the terminal. Now let's run our program. And this time we'll specify a size of 200, and we'll specify a directory of img. And it detects that we have 4 images. We already have the thumbs directory, so we'll go ahead and overwrite it. And we're getting back the same error we had before with 200 and 200 not being acceptable values. So we can come back and again call parseInt on the program size. Run our program again, yes to overwrite, and we recreate our images. All right, so that's all it takes now to define arguments. And the neat thing is, we can flip these arguments around and pass them in any order. So image could come first for the directory, and then size could come second. With Commander in place to define our arguments, we have a bunch of extra functionality baked in aside from just rearranging the parameters. For example, I can pass -h now to get help about this script. And you can see, in addition to usage information, we have automatic help generated that specifies the various different options. For example, we even have a version flag to retrieve the version of our program. You can see we have version 1.0 of our program. You'll also see the 2 arguments that we specified, both the size and the directory, and the values that we passed for the name of the value, and the little brackets indicating that those are required arguments, including our little help blurb that we added to our program. So we get this nice automatic help baked right into our command. One thing you'll want to watch out when using Commander to parse arguments is that if you don't specify arguments you're expecting, you could still run into trouble. So you can see here by not passing any arguments to my script, I'm getting an error because there's no directory called undefined/*.jpg. What we can do to fix this in our script, right after we parse out expected arguments, we can check to see if they're defined. So we could write an if statement and see if the images directory is defined. So we could use an if not images directory. And in this case, we could print out some information and exit from the program. We could start out with images directory expected. In addition, it's usually helpful to print out the help information for the program as well. And you can do that by calling program.help, which conveniently will print out help information and immediately terminate the program. Now, if we come to the command line and we run our script without any parameters, you can see images directory expected. Maybe we need to make that error a little more prominent, and then the help information. So it's a nice convenient way via the API to terminate the program and specify the help information if somebody doesn't pass the required arguments. Now, as far as the images directory is concerned, that's a required argument, so we should bail out if that's not specified. However, the size argument is optional, because we could just use a default size. That makes sense. So what we could do is come up to our options, and on the very end of our options, we could specify a default value. So if one isn't provided, 200 will be used. Just to see that in action, let's echo out the program size. And maybe to see that in action, let's echo that out without specifying the default first. Let's put the default on another line here. I'm going to break out the arguments here on their own line so you can see that. Let's start by first not specifying 200. So we'll echo out whatever size is, and we'll exit out of the program too. Let's run our program. We'll specify the image directory, and then we won't specify a size. Okay, it's undefined on the first run. Let's try running with -s without specifying a value. Okay, we get the argument is missing, which is one other thing I wanted to point out. If an argument is required and you don't specify it, but you do specify the flag, Commander will bail out of the program and print out an error. So the value is undefined if we don't provide a value. Now let's go put that default in, come back to the command line and run our program again, and you can see the default value is used since we didn't specify a value. If we specify 300 instead, that'll be used instead. We've got quite a bit of code here in our script. It's not too much, but one thing that sticks out to me is that all of this code at the top is just involved in option parsing. One of the nice things about using a language like JavaScript is that we can split up and put our code into separate files for separate concerns. What I would like to do is to sweep away some of this code for option parsing into a separate file so I start to have more structure to my script. This will become more important as your scripts become more complicated. You might want to take advantage of creating separate files. So what I could do is come out to my project, create a new file, and maybe we call this one options.js. And of course, if you're splitting your scripts up into separate repositories or folders, then it's okay to use whatever names you'd like. Perhaps in this case, because we have other scripts, we should have named this differently, but whatever, we'll use options.js for now. Then what I can do is come in, yank out the code for parsing options, go into the option.js script and paste that in. So we'll require Commander, we'll set up our arguments, parse those arguments, and we'll pull variables for the images and size directories. Now, these won't be accessible in our other script without exporting them. We also don't need our echo and exit, so let's get rid of those. And we still want to check to make sure the image directory is set before bailing out. Now what we need to do is export the parsed arguments and make those available so we could import them into our module to create the thumbnails. So we can use module.exports. Remember, we're using Node.js here, and Node.js allows us to define our own modules. And then we could specify the images directory, just like we've done here, creating these variables. I'll just yank this variable, paste that in, and we'll use module.exports. And we'll export the size as well, parsed. So now we've swept under the rug all of our option parsing, which one really neat thing is we could change our option parser from Commander to something else, and the rest of our program wouldn't need to know about it. But that's not really the point. I wanted to get this code out of the other part of our program to simplify it. We know now if we need to work on options, we come to this file. If we need to work on thumbnail conversion, we come to this file. Now we can read in those options in by requiring that option script. And this time, this is a local module, so we use // and then options.js. And then we need to redefine those variables that we removed because we expect these in the rest of our script. So we use options.size, and we'll specify the options.image directory. And let's just dump out these values. It's not important that we run through the whole program. Okay, now let's run our program. We still have that the images directory is not defined, except that's not quite in the right place. Let's go back to the code. Made a little mistake there. This should be program.directory. I got rid of that variable. Okay, now let's go and run our program again. Okay, we don't specify the option. We still bail out. So everything's tucked neatly away in that script, including the functionality to bail out if a required option is not present. And then if we specify the image directory, you can see we print out 200 in IMG. If I specify the size, there we go, the size has changed as well. So as you can see, we can sweep under the rug into this options file, all the parsing of options, and get it out of thumbnail conversion. If the rest of this code became more complex, we could even consider sweeping some of it out into its own file. This chapter only briefly touched on the concepts of parsing arguments. I'd strongly recommend to never try to roll this on your own. Always use some type of library to parse the arguments. That way you focus on what arguments you need, not on how you make them happen. Now, we went over some basics of parsing arguments. You might also take a look at some of the coercion of arguments. I didn't get a chance to go through that. You might also take a look at regular expressions to validate values for arguments, so you could constrain user input. And if you needed a program that could take in a variable number of ending arguments, perhaps for a list of files, you could take a look at variadic arguments. And maybe one last neat thing is to take a look at the get style subcommands. If you wanted to write a shell script that had some subcommands, kind of like with Git, how you have git commit or git log, you can create subcommands using the command builder. So as you can see, you can do some pretty complex things with arguments to your shell script. Also keep in mind, there are other argument parsers if you don't like this style. If you want an additional challenge for working with arguments, how about add a -q flag to quiet down the output of our program? When we run this, you can see the output is quite verbose. How about add a q flag that silences all of this output? Another thing you could do is add a flag. Instead of prompting the user add an F flag to just force remove this thumbs directory if it exists. That way somebody could automate this script by adding a -F and get rid of prompting. Just go ahead and overwrite that directory, or remove it in this case, if it exists. So add a -F flag for that. And then you could get rid of the prompt and just bail out of the program if the directory exists with a non-zero exit code. In this chapter, we're going to return back to the example we started with way back at the beginning of the course when I was talking about performing operations from the command line. Now, we didn't take a look at how to do this with JavaScript, but we did take a look at how to do this with PowerShell and Bash. Remember when we downloaded the closing prices for the CSV stock way back at the beginning of the course, and we performed an average on the close to find out what the average close was for the last month? We downloaded that CSV file, and we saw how we could use Excel to sum it up and produce an average. We also saw how we could do that with Bash. Now we're going to return to looking at this, not just so much so that we can see how to do this in JavaScript, but because it opens up the opportunity to talk about working with collections of data and how awesome that can be with a functional language like JavaScript, especially when we bring in a library like Lodash that can give us some really neat functions we can perform on collections of data. I want to show you this so you get your mind thinking about how you can be manipulating data in JavaScript shell scripts, almost as easy as taking a hot knife to a stick of butter. First, we'll need to parse that CSV file before we can take a look at the functional things we can do with the data. To do this, I've created a csv.js script. This will be our shell script for parsing that CSV file. And I've also copied in the CSV table that we downloaded earlier in this course. You can find this in the working files for this chapter if you'd like to use the same example I'm working with. To get started, let's first read in the contents of that CSV file. We could do that with the cat function in ShellJS and specify our table.csv. When I test that that's working, we can echo out the data and come over to the terminal, and we can run our CSV script. Looks like that's working. Next, we'll want to parse the CSV. Now, to do this, we'll need a library to parse CSV. Earlier, we found this package at the beginning of the course that can help us parse CSV. Let's take this thing for a spin. So first, we need to require it, which means we will also need to install it. And don't forget the --save flag if you'd like this to be added to your package.json. Once we have that local, now we can use the parse function. csv.parse. This will take in the data that we would like to parse. And then we'll pass a callback that will be executed, which will of course have an error argument first. And then the records are rows inside of the CSV file. Now, just to see if this works, let's try echoing out the content of the rows. I believe that should be an array. Let's take a look at that. So we have an array of arrays. As you can see here, each record inside of our file is an array of arrays. Now, the first array are the headers of that CSV file. The second array then is the very first record. Now, because we don't want to process the data in the very first row, we could go in and edit the CSV file. Or to make this a bit more flexible, we could just skip that record. Best way to do this, let's take a look at Chrome, and we'll run some JavaScript here in the browser. If we have an array with values 1, 2, and 3, we can call the slice function to slice and create an array with the values after a specified index. So I could specify 1 to slice and only include the values at index 1 and thereafter, which would be values 2 and 3. Now that's a bit confusing. How about we use the same values as the indexes in the array? Now if we slice at 1, we get 1, 2, 3, and 4. If we slice at 3, we get 3 and 4. So we could use this to slice off the very first item in the array. We'll slice starting at index 1, which is the first record in our data set. Come over to the terminal, run our program again. This time you see the header is not included. All right, let's not print out the records. Instead, let's go ahead and produce the average like we were talking about way back at the beginning of the course, the average of the closing price, which was in column 5. And of course, if you're wondering how to do this, well, one quick and dirty way would be to define a sum variable to count up all the values of the close prices, and then also to define a count variable to count up the number of items so that we can produce an average. Then we could take the rows and we could iterate through them with for each. And for each row, we could increment the count, and then we could add to the sum the value of the current record. And that is column 5. Let's double check that though in the CSV file. 0 is date, 1, 2, 3, 4. Sorry, it's column 4 in 0 indexing. Now the other way we could do this, instead of keeping a count, as I'm just thinking about simplifying this, we could use the length of the rows array. Now with the sum and the count, we can print out the average. Now we might want some error handling for the case where there are no records, but aside from that, let's go ahead and run this. And for some reason, we're getting not a number. And that's because, and we need to come back to our CSV script, we need to parse the values from strings into floating point values. When we read and parse the CSV, all the values come back as strings. So we'll parse floats for the values and then add those onto the sum. Now when we run our program, we get an average of 23.7155, which sounds very familiar to what we were looking at way back at the beginning of the course. I'm going to take off echoing the data. We don't really need to look at that. All right, so while this works and is sufficient, it's quite a bit more complex even than the Bash version. It's a little bit easier probably to understand because we have nice APIs like csv.parse, we have rows, we're producing a sum, it's sequential code that we can read through, but this is rather convoluted. We really just want the sum of the records. Why do we need to spend so much time doing that? Why do we have 5 lines of code to figure that out? Couldn't we collapse that down to 1? That's what we'll look at next. There's a really clean way that we can compute this average closing price using a functional library known as lwDash. Let's pull this down into our environment and then we'll take a look at what we can do with it. So first let's install lwDash. Make sure the save flag is added if you want to add this to your package.json. Okay, so we have lwDash installed. Now typically, an underscore is used to refer to this library, and that comes from the history of this being a replacement to the underscore library, which is still extremely popular and would also work well for this purpose. Let's require this package, load up this module. Okay, if we scroll down in the documentation here, you'll see there are a bunch of different functions that can be performed with lwDash. And there's one in particular that you can find by searching for sum that we could take advantage of. So there are a bunch of math methods. You can even click on one of these links here and go over to the documentation for lwDash. If you look for sum here, you'll see underscore.sum. And you'll see we can take underscore.sum and pass to it an array, and it'll produce the sum of the items in that array. Unfortunately, at this point, we don't have an array, but we could make one. And we could produce an array using the map function that's available on the array prototype in JavaScript. This is a functional function that's already built into processing arrays. After we slice off the first item of our array, we could chain a call to map. Map takes a function, and we could specify a more verbose function with row, and then that function returns a new value, we map or project a new value. So what we could do is return, in this case, the column that we want out of our CSV file. We can save that then, and we could go ahead and we could log out the value of this. We come back to the command line and run our script again. There you go. You can see we have just an array now. In fact, I messed up the averaging function. Who knows what it's doing at this point in time. You'll also see that those array values are strings. We want them to be floating point numbers so we can sum them up. So we could add in a call to parse float. When we run that again, now you can see we have floating point numbers instead. Now we could leave this as it is, but we can clean it up a bit. We can clean it up by using a fat arrow function instead. These were introduced in ES6, now known as ES 2015. So a somewhat more concise way to express this function that simply takes in a row, grabs the fifth column, parses that into a floating point number, and then returns that value. Now we could leave this right here. We can take one further step though, clean this up a little bit more. We could call map again, and this time we could pass in parse float. So we can chain together calls to map. First, we can map and pull out the fifth column. Then we can map and convert that to a floating point number. If we run this again at the command line, you can see we still have the same result. To better understand what's going on, let's print out what we have at each stage. There will be a lot of data here, but I think this will help you understand what's going on. So let's echo out the rows first. And right before that, let's say stage 0, CSV rows. So that's our first stage. Now let's grab some intermediate variables. So let's first produce data rows, and this will not include the header row. Now for this, we'll echo out stage 1, data rows. We'll use the data rows then as a matrix out of which we pull the fourth column. So what we have now are the closing prices. And perhaps since these are string values, we could even tack on string values. It's a bit verbose, but it's going to help us understand what's going on in this pipeline. Stage 2, closing price, string values. At this point, we can pull this back to and just get this collapsed down to one line. And then lastly, we take our closing price string values and parse those into floating point values, at which point we really just have closing prices. For this one, this will be stage 3. So each stage, I'm denoting what's happening in that stage. The very first stage is just printing out the CSV rows, which are really parsed right before we called csv.parse. It might make more sense to lift this and put this before a call to csv.parse. So a first stage involves parsing, but I'm calling that stage 0 while I'm confusing myself. Stage 1 then involves removing the header row. Stage 2 pulls out the closing price string values as a column, and stage 3 converts those to floating point numbers. Again, we could pull this up a line and clean this up a bit, and we'll need to echo out the closing prices here. And we should echo out the closing price string values as well. And we'll echo out the data rows here. So we're printing out the values at the end of each stage in our pipeline. Now we haven't quite got to fixing up our sum yet. Don't worry, we'll get to that in a minute. Let's come back to the terminal. Now let's execute our script again. A lot of output here. Let's scroll up though. Some redundancy. All right, so at the very first stage, stage 0, we have just the CSV rows, including that header column. Scroll down here to stage 1. We have our data rows now. We're not including the header row anymore. Scroll down a bit more, stage 2 then. You can see we've extracted out the closing price column, and they are string values. And then stage 3, you can see those are floating point values. So we've created a pipeline to process our data. And that's the beauty of using a functional language like JavaScript, is we can create these beautiful pipelines. At this point, this is verbose, but you just saw a few moments ago how compact and concise this can be. Let's go back to what we had here. So we can blow away all of our echoes. Okay, when we go back to the more compact version here, you can see we have a nice chain of calls here, out of which we get the closing prices. Now we can take advantage of this sum function provided by Lodash. So to do this, we can come in right after our closing prices, _.sum, and pass in closing prices. That's all it takes to produce a sum. Grab that, replace all this code down here with that, go back to the terminal, run our program again, and you can see we have an average value, though something looks off. And the problem here, we're using the length of the wrong array. We have one extra value. There we go. Now, the important thing with this refactoring of this code is that we point out how easy it is to work with collections of data in JavaScript. We take our rows, which is a matrix of values, we slice off the very first row, then we map that matrix into a column of values, a simple array. take that array and we map all the values from strings to floating point numbers. So we're performing manipulations on different sets of data and transforming that data all along the way through our pipeline. Now this refactoring we did, the nice thing is we no longer have to manually go through and sum up the values in the array. And something really neat has happened. Because we are processing our data as if it were in a pipeline, we've split apart the code necessary to get the closing prices from the code necessary to produce a sum. So we've injected some separation of concerns here. And in fact, we could take this a little bit further. We have the average value here. We could extract a variable for that called average. We could take the values we have here for closing prices, and we could extract a function, and we could call this function average. And just like that, we now have a function that computes the average. And we could reuse this function then to compute averages of other sets of data. We've separated our concerns here. We don't really care how we produce an average. That's a concern of this function. In fact, this function can now take care of the case where there are no values. We could even rename this to just values. And we could handle edge cases here. We can sweep away this average function because we don't care. In fact, I'm rather surprised that average isn't defined in lodash. Some is. Seems natural for average to be an extension of that, and I'm sure you could find that on npm or create it yourself. The nice thing here is we've separated concerns, so now in our function to parse data, it's much more clean to understand that we're producing an average of closing prices and printing that out. In fact, I wouldn't be too opposed to just inlining this variable here right inside of our output message, unless we needed to use the average for something else. You're just not going to have a lot of the constructs like this if you're working in a PowerShell session or a Bash session. You'll have the constructs. Even PowerShell has some of this functional pipeline and processing in it, but it's often much more intuitive in a functional language like JavaScript, where this is a front and center concept that maybe you've already encountered. I'm sure you've seen some code like this before, perhaps run into some scenarios that could benefit from this in developing regular code for regular applications. Why not take advantage of these functional pipelines and shell scripts as well? It's not too uncommon to expect that you'd have some data you would want to manipulate in a shell script. Why not have a language that helps you do that rather succinctly? Taking a look at the average only gave you a taste of what you can do with lodash. Let's take a look at a few more things here. In addition to computing the average, we could do things like sort data really easily. Now I'm going to drop off the very first row and just say data rows and create that as a variable so that we can work with, in this example, code that's independent of taking off that header row. All right, so we have the data rows in our application. What if we wanted to sort all the rows and just see the daily closing prices sorted by the closing price? Well, with lodash, we can call underscore as a function and pass in our data rows. And then instead of our calls to map, we can use sort by instead. Sort by then will take a function. We can use a fat arrow function here. For each row, we can sort by, parse the floating point number of that fifth column. What we've done here by calling underscore as a function is to open up a chain of operations that we can perform. Now at this point, we're only going to call it sort by. So there's only one operation we're going to chain, but I really like how this reads. Look at this, data rows dot sort by, and then what we sort by. Well, we parse a floating point value out of the fifth column. So this reads really nicely as to what we're performing. Now, because we used underscore in this fashion, to evaluate this and to actually perform the sort, we need to call dot value. Now we can echo out the closing prices. And really, we're not echoing out closing prices anymore. We're echoing out the data sorted by closing price. If we go to the terminal and run our program again, you'll see we have in the fifth column is 1, 2, 3, 4, 5. It's right before this integer number that separates out the floating point number. So 24.94, 24.87, 24.87. And to help us out, I went over to Excel and sorted the values for us. You can see 24.94, 24.879, 870. So we're getting the same values if we scroll up to the top here. You can see the lowest value of 21.4599. And Excel confirms that as well. So as you can see, lodash is a great way to perform manipulations on this data. Think if you had to create another array, try and sort the values of the different rows in that array while trying to simultaneously put those rows into the sorted order. It's a lot of concerns going on. Really easy for you here to spin up a chain of operations with lodash, perform a sort, and then grab the value of the records in the sorted order. Before we wrap up, let's take a look at one more thing that I guarantee you would be very, very difficult to do from any bash shell environment or really any traditional shell environment. Let's say we have these closing prices and we would like to group our prices by the week that the date of the price falls in. So these are all sorted at this point. Let's say that 11/2 is one week, 11/9 is another, 16 is another, etc. I don't know where these exactly fall at, but somewhere roughly in here. What if we could group by these different weeks of the dates involved? And then for each week, what if we could produce an average closing price for the week instead of just for the whole period of all the dates involved here? Seems like a bit of a challenge, right? But you know what? It really isn't when you have a functional library like Lodash in combination with a functional language like JavaScript. What we want to do is take our data rows, just like we have before. Instead of sorting, we can use a group by function. And a group by, much like sorting, takes something that will tell what to group by. And that something is a function. Again, we can use an arrow function to keep this concise. What we want to do is return the date value. Now, we could try grouping by the date value, and that wouldn't be exciting. But let's just see what that looks like first. And for now, I'm going to rename this weekly averages. All right, let's run our program now. And as you can see, we get groupings here, but the date values obviously are all unique, so each of the groups doesn't share any values. You'll notice that for each group that comes back, we have a key on an object. So we have one giant object that gets returned back here, and we have a key for each day for each group, depending on however we had grouped. And then inside of that key, we have an array of the values that are in that group. Obviously, there's only one value for each day. We could take this a little further. We used that moment library way earlier in the course. This is a great Swiss Army knife of working with dates in JavaScript. And one of the things we can do, we can create an instance of a moment object, and we can call .week to get the week of the year. So we could group by the week of the year, which gives us the ability to group dates by the week that they're in. If I run our program again, you'll see now we have the 49th week of the year, contains 11/30. The 48th contains 11, 27, 25, 24, and 23. So each key now is the week of the year. And then the values array has all the dates that fall in that week. So we've now grouped all of our records by the week that they're in. Now we can continue our pipeline here. And this is one of the big benefits of opening up a chain of operations by calling the underscore function and passing our array of values in. Because now we can call map to produce the weekly averages. This map function will take in two values. And that's because when we call group by will return that giant object, which has keys and values, key value pairs. So we're mapping over an object in JavaScript. So we're going to go through the properties or keys on that object, and we can iterate through each key and each value. Now, it just so happens to be that the value comes back first and then the key comes back second. And this is for each group. So we're going to map through each group and produce a new output. So the first thing we want is to keep the key, which will represent the week of the year. So in our map function, we will return back the key as it is. We'll take our values, though, and we'll produce an average on the closing price of those values. And remember, those values are the same format as our data rows. It's just a subset. Remember, we sliced off, at certain points, subsets of this data set. And that's what we have in our values at this point in our function. So what we can do then is open up another chain with Lodash, pass in the values, call map. For each value, we can extract out the fifth column, and we can map and parse a float. And then we can call value to end the chain and get the parsed out floating point values for the closing prices. So this will be closing prices. Now we can return then the average closing price. And we can compute that with our average function. Isn't that nice that we split that apart? Looks like I have a little typo in here. We'll fix that. Okay, what we've done is we've grouped by the week of the year. And then for each week, we're computing an average closing price. Now, I don't have all the data for the entire year, so it's very possible some of these values will be off. And it's also very possible that how I average this is not the official way to average it. But let's go run this and see what happens. And as you can see here, for key 45, 46, 47, 48, and 49, here are the average closing prices. Now, these keys aren't so helpful. How about instead of that, we come back and we set the key to be one of the days of the week. So let's just go into our values array, grab the first one and grab the first column, which is the date. So we'll grab one of the dates in our week so we know which week it corresponds to. Run this again. Now we have dates. Now I can't guarantee which date of the week that happens to fall with, but we have something to correlate now. If we hop over to the Yahoo historical prices, I've already loaded this up here. I've run November 1st to the 30th and pulled all the weekly prices. And you can see for November 30th, I have November 30th over in my data set here as 24.69 for November 30th. Then we have 24.79. That's pretty close. 24.09 is not quite 0.20, but we're pretty close here in our values. Again, the official way this is computed is probably not how I'm computing it. Nonetheless, you can see with a couple of lines of code, we can easily do some very advanced things with grouping and projections, averages, sorting, etc. I'd encourage you to take some time to go look at the Lodash library and check out all the things you can do with this to manipulate collections in JavaScript. You can build some pretty robust pipelines pretty quickly with a couple of lines of code and do some pretty neat things from the command line. Thus far in the course, we've been relying upon calling node and then passing in our script to execute, followed by any arguments. And while this works to get started creating shell scripts, and this might even be viable for one-off shell scripts that perform a transformation or a manipulation of some files and produce some information that you only need to use one time, if you want to reuse these scripts, it would be nice if you could write out and call these scripts in a fashion that's much more like executing any other command line application. I'm going to pipe the output here to dev null, just so I can leave this command on the screen, and we could compare it to an alternative syntax. So what I'm talking about is it'd be nice if we could just run Pretty XML from any location on our computer and pass in whatever XML file to it. That way we could use this anywhere we'd like. For example, when we downloaded these XML myFoodopedia data files, we could just cd into this folder and we could run the Pretty XML command on each of the files without needing to path to them from the location where our script resides to simplify passing our script to Node.js. In other words, what if we could just run this Pretty XML command anywhere on our system and pass in an XML file? And that's what we're going to look at in this chapter. And we'll do this with a three-pronged approach. First, I'll show you with Node.js how to set up an npm package, which is really what we're creating, that we will install globally on our machine so we can access this shell script from anywhere on our computer. Then I want to dive under the hood and show you a bit about how all of this works when you install a global package with npm, how that works to add that package, and specifically to add our shell scripts as executables into the path on your computer. And I'll do that both on a Mac and Windows so I can show you the differences between the two. Even though there's nothing that you have to configure differently to get this to work on both of those platforms, I just want to show you under the hood how they're different, what Node.js and npm are doing behind the scenes. The last thing we'll take a look at is how you can package up and share your code easily with other people. To create a command that we can access globally, we'll need to set up our code as an npm package, and then we'll need to install it as a global npm package. In setting it up, we'll need to specify the scripts that we'd like to be available when we install our package globally. To do this, we'll need to go and open up the package.json file we created when we called npm init a while back in the course. And we did this so we could keep track of the dependencies that our shell script relied upon so that we could move these over to another computer and easily install them there. So we've already taken care of one of the major hurdles, and that's needing to specify the dependencies of our shell script. The next element we'll need to set up is the bin property, and to understand what that configures, we'll need to hop over to the documentation for the package.json file. You can Google for this, or you can find it on docs.npmjs.com. You'll see there's a configuring npm section and then a subsection for package.json. And this lists all the various different properties that can be configured inside of that package.json file. For example, if I look here for dependencies, you'll see the dependencies section that we just mentioned in our package.json file explains how this dependencies section works. If I search for bin, if I click on this link, you'll see in the URL a link you can use to access this. If you access #bin, you'll be able to jump right to this documentation. Bin allows us to specify executable files which we'd like to make our shell scripts into that are a part of an npm package. So what we can do with this bin declaration is list out the various different shell scripts that we'd like to make available when somebody installs our package. And the important part here is that we use this configuration block, this bin configuration block, to specify a mapping of the command name to the local file in our project that will be executed when that command is triggered. So we can specify a different name than the script that we have our code inside of. So if we hop back to our configuration file, let's say we want to make Pretty XML available globally, and we'll leave the command name the exact same name as our shell script. So Pretty XML. If you wanted to change it, you could set a different name here. For example, if you wanted Pretty-XML. And then next, we need to specify the location of the script that will be executed. And in this case, we can refer right to the pretty.xml.js file right in the root of our project. If it was in a different folder, we could path to that as well. It's worth noting we could add other commands for other scripts that we have as well, so thumbnails. And if we wanted, we could call this thumbs instead of thumbnails. And this would refer to /thumbnails. So as you could see, one of the things you could do is create a repository of your own shell scripts, and you could just list out all the shell scripts in here as you create them, and then reinstall your package each time you add a new shell script or change a script, or update your package. And you have one registry, if you will, of all your shell scripts that you could start using. You might also want to break these out into separate repositories. That's completely up to you. But you can see you could create a dumping ground, if you will, of little shell scripts that you create that you could then use globally. And you can come into this bin configuration and create a little registry of the various different shell scripts that you'd like to make available as commands globally on your system. This is the first step. The second step is to go to these individual scripts then, and we need to denote with a shebang that these are scripts that should be executed with Node. We can do that using shebang notation, specifying user bin environment, and then specifying the Node executable. Copy and paste that exactly as it's typed here. And you'll need to put that in the top of each of the scripts. However, I won't put it in the thumbnails.js script so that I can show you what happens if you don't include that. Now, to make this work, we can come over to the command line. And from inside of the folder where we have our package, notice I'm inside of JS Shell right now. From inside of that folder, we can run the command npm install, just like when we are installing dependencies locally to consume inside of our shell script. Except now we add a -g for global. So we would like to install a global package. And the global package we'd like to install is the directory we're inside of. So I'll just put a dot to refer to the current directory. Now on a Mac, I need to run this as an administrator, so I'll include a call to sudo. And that will go off and install our package globally. One thing this will do that'll take a little bit of time since we're installing this globally for the first time, lwIP will need to run through and recompile all the C++ code. So that'll take a little bit of time. Don't worry, after you've installed this the first time, unless you update lwIP to a new version, you won't have to recompile it each time you install your package globally or update it globally. Unless you update the lwIP dependency, you won't have to wait for all of this to happen again. Once that's done installing, now we should have access to our Pretty XML. If you see here on a Mac, if I type in PRE and hit tab to use tab completion, there's Pretty XML. Now, to really test this out, let's go to our downloads directory, where I had downloaded all those XML files, list out the contents here. I should be able to run Pretty XML on any one of these files. And there you go. If I want to run it on a different file, there you can see it works on a different file. So from anywhere on our computer now, we can access our Pretty XML script. We also installed thumbnails, or thumbs. If I run that though, you can see we have an issue. We get an unexpected token requiring ShellJS. And that's because we left out the shebang to indicate that this script needs to be executed with Node. Next, let's take a look under the hood what's going on to better understand how Pretty XML is working globally, and also to understand why thumbs is not. And we'll do this both on a Mac and on a Windows machine so you can see the differences under the hood with what's going on with shell scripts, and why they work without needing to configure anything differently between the two environments. So how in the world do these global packages work? Why is it that one of our scripts, the Pretty XML shell script, worked just fine, but this thumbnail script didn't? Well, as it turns out, since we didn't add the shebang to the beginning of the thumbnail shell script, what happened was more or less we tried to execute that JavaScript file as a regular shell script. For example, if I go back to the directory where my code is at, list the contents of the directory here, and I will list all the attributes of the files in this directory, you can see right now thumbnails.js is set into pretty much read-only mode. If we change the permissions on this file to allow us to execute it, we add the execute mode, then we could execute this thumbnail script like a regular shell script. And you'll see we get warnings that look exactly like what we got when we tried to run these via the global command that npm added for thumbs. So you can see the syntax error and the require statement are the same in both cases. And this makes sense. Obviously, if we're running this as a regular shell script, Bash has no way of knowing what this JavaScript stuff is. Behind the scenes, when we execute one of our commands, the command is located inside of this user local bin directory. Let's take a look at that for a minute. So when we type in Pretty XML is located in our path, but to find out where it's located, let's use the which command. You can see it's located in the same location as thumbs and user local bin/prettyxml. If we list the contents of that location, you'll see that this is a link to a file in another location, prettyxml.js. So this is just a symbolic link over to our shell script that, when we installed it globally, installed into this lib node modules folder. We can take a look at that directory, and this is where our package was globally installed at. And you can see all the contents of the project that we have been working on thus far were copied over to this directory as well. So when we type in prettyxml to execute our shell script, this JavaScript file is executed as if we had made it executable and then executed it from the command line ourselves, just like that. However, it's a much more concise syntax, running it as if it's a command installed on our computer. This symbolic link for prettyxml is the same for the thumbnail script. If I list the contents of the user local bin thumbs, you'll see it's also a symbolic link to the thumbnail.js script, which is the same one that we have in our project, and you know there's no shebang at the beginning of that file. So there's not a lot going on here. There's not a lot of magic behind the scenes. At least there's not a lot on a Mac. Let's hop over to Windows and see what's going on behind the scenes there. Okay, I'm back over on my Windows box. Let's take a look at the same thing we just took a look on the Mac. What I've done here is I've copied over all the files, including the changes we made to pretty.xml and the package.json file. So at the top of pretty.xml, we have the shebang. Keep in mind, we don't have that at the top of thumbnails, so it's not there. And then I also have the package.json file that's updated, so we have our executables specified as prettyxml and thumbs. So we can do the same thing here in Windows, npm install -g for global, and then dot for the current folder for our JS shell package. This will globally install. Remember, on Windows here, we'll have to do the same thing we did on our Mac. On the very first run of this global install, we'll globally install the lwIP package, which we'll have to recompile. Now that our package is globally installed, and we can check that it's globally installed with the npm ls command to list packages, -g for global, and then also specify a depth of 0 so we don't show any dependencies of these packages. You can see right now this is a dependency graph. We would produce the same thing here if we didn't specify -depth 0. All we care about are the packages that we've installed globally. Okay, now that we've run npm ls, you can see we have JS shell installed at version 1.0.0, just like we had on our Mac. We should be able to type in prettyxml from right here, and you see our program runs, though we didn't specify an XML file, so we get a file doesn't exist. And we also should be able to run our thumbs program. Of course, this should error out. And actually, something interesting happens on Windows. The thumbnails JavaScript file opens up. It's a bit different than on the Mac. And that's just in how files are handled between the two operating systems. On the Mac, this thumbnail.js script is attempted to be executed as a regular shell script, and that errors out. On Windows, well, there's a shim that's generated by npm when we install this globally, and that shim just points at this file, and the behavior inside of a command prompt will be just to open up that file. Okay, so behind the scenes, what's going on here? Well, as it turns out, on Windows, we go up a couple of directories and then into app data, roaming, and npm. This is where our packages are installed out on Windows. If we do a dir on this folder, and we look for prettyxml, you'll see there are two files in here. One's prettyxml. The cmd file is what is attempted to be executed here on Windows. Now for the prettyxml.command file, and by the way, if you want to find where these are at in your system, these could be in a different location depending on how you install Node. You can use the where command and type in prettyxml, much like the which command on macOS. You can see these are located at the location we're taking a look at right now. Anyways, if I output the contents of these files, first prettyxml, that's a shell script. You can see a shebang with bin/sh. Somewhat like specifying we wanted to run with Node, but a little bit different. So there's a shell script that's generated, and this is meant if you have Cygwin on Windows. That command script is one we're interested in, so let's cat the contents of that with the type command. Okay, so this one, the bulk of what's going on here is that we're executing our script with Node.js. So we're calling Node and then prettyxml.js. More or less, this little shim takes care of us typing things out like this. And it also takes care of letting us type this in anywhere we want on our system with that simple prettyxml command. However, that thumbs command, that's where things are different. I wanted to show you the Pretty XML first so we could take a look at thumbs next. So if we just do where thumbs, you'll see we have 2 files in here as well. And I don't care about the shell script. What I do care about is this thumbs.cmd, which is executed from the command prompt here. If I cat out the contents with type, I know that's confusing, but that's how things work in a command prompt on Windows. You'll see this is a different file. This is a script we have for Pretty XML where we had the shebang at the top of the file. This is a script we have for our thumbs shell script because we didn't have the shebang at the top of the file specifying that we want to run with Node. And this is why we just open up the JavaScript file on Windows. That's all this command is doing. So when we fix and add the shebang to the top of the thumbnail shell script, the script will look like this instead. And that's what we'll turn to looking at next. We'll take the time to go through the process of updating our shell script to fix the thumbnail command, and I'll show you then how you can update your package globally. Let's take a look at how we can update our package. Now in this case, let's go about fixing that thumb script to make it work. In reality, you would want to use this whenever you make changes to your shell script and want to put that shell script back into your global scope so that you could perhaps test that script on your local machine. So first thing first, that thumb script still doesn't work. If we hop over to our editor into Pretty XML and copy the shebang, go over to our thumbnail script and paste it into the top, save that, go back to the terminal, you'll notice when we run our script, it still doesn't work, and that's because we've updated the local copy of our script, but we haven't updated the global copy. Now, there are a couple of ways you could go about updating that global copy. The formal approach would be to run an npm update to update the global package. However, this requires bumping version numbers locally every time you make a change, and that's quite the hassle. I don't think it's worth the time when you're developing a shell script and you just want to test things out locally. What you can do instead, then, the easier way is just to mash over the top of whatever's installed globally with npm install again -g, and then dot to reference a current folder. This will just mash over the top and ignore version number differences. Now when we run thumbs, we don't choke out, and we get our help because we didn't specify the parameters that were expected. And of course, our Pretty XML still works. That's how you can go about updating your package as you're developing it locally. Next, we'll turn to talking about how you can go ahead and publish your package and share it with other people. Out on the npm documentation, there's a great video to walk you through what it takes to publish a package to the npm registry. I won't reproduce that here because this video already takes care of that for you. You'll find a little bit of documentation down below as well. You can get to this by going to the docs, and you could type out this whole link, or over in the left navbar under Getting Started, Step 12, the tutorial is Publishing npm Packages. What I want to talk about are a couple of different strategies you can use to publish your packages. First off, you could work out of a local directory like I have here, and perhaps synchronize the files somehow, either through version control or perhaps through something like Dropbox, onto the various different computers you would like to run your script on, and then you can just use npm install like we've been doing right inside the folder where the code is at. But I don't think that's a good long-term strategy. While that's great for developing a shell script, why not take advantage of the functionality of npm to be able to install packages that are published out to public locations? Now, there are 2 ways I'll recommend doing this. First is with the npm registry if you'd like to share your package with a lot of people. However, it's very possible you'll develop scripts that you don't care to share with other people, perhaps because you don't want to update them and fix bugs for people using your package in ways that you didn't intend, or perhaps because there's private or confidential aspects to your packages, in which case you might want to publish your package somewhere else in a private location, or you might just want to publish your package into a more private location than an npm registry. Now, one way you could do it is you could spin up your own private npm registry. An easier way, though, is just to publish your package to a Git repository. And you could do that if you don't care if it's public, you could put it out on GitHub. And if you do care about it being public, you could put it on a private Git repository as well. So those are all different sources where you can publish your package. And then all you need to do from the command line is tell npm the location. If you don't specify location, npm by default will look at the npm registry. If you specify a file location on disk, npm will install it locally from that file location. Or you can specify a Git repository, and npm will install from the Git repository. So those are your options about how you can publish your package. So you can imagine the workflow will be pretty simple. For example, you could publish your code out in a Git repository on GitHub, and then from each of the machines you'd like to use your packages on, you could just come to that computer, run an npm install -g, and pass in the Git repository, and off you go. You have your package installed locally. Especially if you build up one repository with a bunch of your little helper scripts in it, you just have to install one package and have access to all of these different shell scripts that you've created. You can update them from anywhere and then push them out to that Git repository, and then you can update that global package on all your computers to pull down the latest version of your shell script. And that'll work really nice in concert with a Git repository. And I really recommend that approach of using version control, because why not take this down the road that you're used to when developing regular application code and version out these shell scripts so you can see what you've changed over time, access past versions. And if you're sharing this with other people, they can pull down the latest version and they can see the changes you're making, perhaps even contribute to these shell scripts as well. Why not take advantage of people's tendency to use a version control repository for doing JavaScript development? That's something that's already normal. And you can use that for shell scripts as well. You could obviously use Git repository to store your shell scripts, even if they weren't JavaScript shell scripts. Throughout this course, we've created several different code examples, some of them rather complex, like the weekly averages here. As we were developing those, we were making changes to our shell script, and then we were going over to the terminal and running our shell script, and then coming back and making more changes, and then going and running the shell script again to see if the changes we made produced the behavior that we desired. It might be nice to have some other means, though, beyond simply running our shell script to know that the code we're writing works as expected. And that's where we can take advantage of the plethora of tools in the JavaScript ecosystem to help test an application, to write automated tests of even something like code in a shell script. That's what we'll take a look at in this chapter. And we'll do that using a tool called Mocha to write some tests of our weekly average function. Tests that will hopefully give us a bit more confidence in the code we're writing, even if it's code that just lives inside of a shell script. Now, I'm not advocating at all that you have to write tests. This is for scenarios where you have a shell script that might live for a long time and you'd like to preserve the behavior, and you feel like it would be better to have a test to help you out with that. You don't have to. In some of the cases, if you wrote that thumbnail conversion script and it was fine as is and you never saw a need to change it, well, you could leave it as is. There's no reason to write tests for it. This weekly averages, it might actually be easier to write the tests in the first place to help you make sure that your function here that's computing a weekly average even works in the first place. It might be easier in this case to write a test instead of to go back and forth to the terminal to see if your changes work. So again, always keep in mind that you have to balance when this does and doesn't make sense, but it's a tool that's available in your arsenal, especially when you're working with JavaScript shell scripts, again, because of the plethora of tools for testing in the JavaScript space. The very first thing we'll need to do is install Mocha. And this time, instead of -s save alone, add a -dev onto the end of this flag. Our testing libraries are only development dependencies. They're not real dependencies of this code base. If we save them with -dev instead of just -save, they'll go into a special section inside the package.json file for development dependencies. So if I print out the contents of our package.json file, you'll see a new dev dependencies section with Mocha inside of it, which means when other people install this JS shell package, they'll only install these dependencies. They won't need to run the test to use the application, so they don't need Mocha installed. And then let's make a directory to hold our tests. And then we'll create a file called average_tests.js inside of that test folder. And then we'll go ahead and open up that average test JavaScript file so we can add some test code to it. And I went ahead and pasted in a very first simple test case just to make sure that the Mocha framework is set up and we can run through our tests here. A couple of things about this test. First, we're importing the Node.js assertion module. So we'll have access to this assert module that has various different functions that can help us test some basic conditions. In this case, all I'm doing is making sure that the number 1 is equal to the number 1. You can check out the documentation for this assertion module under assertion testing in the Node.js API documentation. You can specifically look at this equal function we're using right now. Now, this is just a built-in assertion module. It's not very elegant. There are other assertion libraries that you can use with Mocha. One of my favorites is Chai, and you can see a link to that out on the Mocha documentation. There are various different assertion libraries you could use. There are 5 of them listed here. But we'll just use the basics in Node.js because this is not a course on testing. The rest of this example just sets up a test, calls to it, declare test. This is a test name. And then this is the code that will be executed when this test runs. Describe blocks, you could think of these as namespacing different tests. You could nest different levels of descriptions to group and organize tests together. Okay, now to get these tests to run, there are a couple of different routes we can take. Right now, we installed Mocha locally as a dependency in our projects. Over in the package.json, it's installed as a dev dependency. We could install Mocha as a global dependency on our computer, and then we could access Mocha right from the command line to be able to run our tests. But a typical convention is to update the scripts in the package.json and to update the test script. And inside of here, since we installed Mocha locally, we'll have Mocha available in the context of executing this test script, which we'll see in a minute. But we can more or less run the Mocha command from this scripts block by specifying it here, and then I'll show you how to execute this in a minute. We also need to pass to the Mocha command the test directory that we created. Now again, at the command line, Mocha is not available, and that's because we installed it locally as an npm package. We didn't install it globally. If we installed it globally, we'd have a Mocha command at the command line. You could add that as well if you want. But because we created that test script with npm, we can call npm test now, and that will reach into our package.json and execute whatever is inside of this test script. And when npm test is run, because Mocha is available locally, it will be available for the context of npm test. So when we run this, you can see our tests fire off. We get some output from Mocha saying that 1 should equal 1 is a passing test, and we have one passing test that took 11 milliseconds. If you wanted to, you could do npm install -g Mocha to bring Mocha in globally. Now we could just type Mocha tests here, but it's also just as easy to execute npm test. And then the nice thing here is we can check this into our repository, and this test script is a common convention with npm packages, so other people not familiar with this project would know to look here to see if there are any tests for this npm package. If we go back to our tests and we change one of the values to 2 instead of 1, come back to the command line and run our tests again, you'll see we have a broken test and we get some information about what went wrong. 1 is not equal to 2. So this is a trivial test. Next, we'll take a look at how we can write a test for our weekly average, though, something we care about. Okay, so let's see how we can test this weekly averages code. First thing we'll need to do is we need to extract this code out somehow so we could access it from the context of a test. We have a variable here for data rows, but then aside from that, I believe everything else inside of this code block is pretty much self-contained. So what we could do is extract out a function to compute the weekly averages. So I can select all this code and extract a method. I'll put it in the global context so we can lift it out. We'll just call this compute weekly averages. We could be a bit more specific about that, but we're just running through a sample set of code here. Okay, so we have this compute weekly average, and this is a function now we could test from the context of one of our tests. To do that, though, let's go ahead and yank this out and put it into its own file. So we'll cut this out. Let's make a new file for this. The reason I'm doing this is we don't want to parse and execute our CSV code just to be able to load up the code and access this function. So we'll create a new module for this. Just call it averages. And we'll paste this in. Now, a couple of things. We'll need access to lodash, so we'll paste that in. And then we also use our average function over here, so we'll move that as well. And then we'll need to export these functions. So we'll export both the average and the compute weekly average. Save that then. So now we'll need to use these in the context of our CSV shell script. Looks like we also no longer need underscore in here. We're not using it anymore. And moment looks like we need to move that over as well. And that makes sense because we're using that to determine the week of a date. So bring that over. So what we'll need to do is pull in our averages, and then we'll need to use that here, and then call compute weekly average and pass our data rows. That way our shell script still works. Get rid of this comment down here. Let's first just test out and make sure that our shell script still works. We'll call node, and then pass our CSV shell script, and it looks like everything still operates successfully. So let's come back to our editor and let's go over to our test now. And let's take with us our require for the averages module. We'll need to change the path for that. We'll need to go up a directory and grab the averages module. So inside of this test, it would be nice to write some code to verify that our weekly average code works as expected. To do that, aside from updating the name of these tests, we'll need to have some data rows in an array. We don't have those yet. We'll get those in a minute. And then we'll need to take those data rows and pass them to the averages.calculate weekly average. And then from that, we'll get back the weekly averages. We'll use those weekly averages then to write some assertions, but let's not quite get that far along yet. In fact, let's just log out the weekly averages inside of our test. We can write some assertions on it in a bit here. Let's hop over to the terminal and run our tests again, npm test. Looks like at least the test is passing. So now we can go ahead and set up our data rows. Now to help us out with this, let's go back over to our CSV script and let's cheat a little bit here. Let's echo out the data rows right here, and we can copy the values and bring them over to our test. So let's run our shell script again. We have some data rows here. We don't need all of these. Just a few of these will suffice. Come over to our test, and we'll paste these inside of our data rows array. Now let's see, 1130 and 1127 will probably fall in the same week. Actually, as it turns out, 1130 is in its own week, and then 1127 and 25 are in another week before that. So this works perfectly because we have 2 weeks in our data set now, so we should get 2 rows back out. And the second set will include an average, whereas the first will just be this 24.69 value. Okay, so I cleaned up the data rows there a little bit, and we can come down now and start to write out an assertion. Join me in the next video where we finish out this test of our weekly averages. Okay, so let's go about writing the assertion for our test here. Now, one thing I did was reformat these data rows so they're each on their own line. Reads a bit more like a CSV file and also allows me to show you the entire test case here. So in piping this information in these data rows into compute weekly averages, the records will be grouped by week. And I've already told you that 1130 is in its own week and 27 and 25 are in the week before it. So what we should do is set up our expectation for the output here. Now, if we go look at the compute weekly average function again, we know that we project objects into an array as the final result, and each of those objects has a key and an average closing price. So what we should expect to get back is some sort of array, and inside of that array, there will be objects with key, colon, a date, and then the average closing price, and that'll be some floating point number. We'll have 2 of those in this case, because we have 2 weeks. And one of those weeks is definitely going to have a date value of 1130 because there's only 1 day in that week. This other one, I'm just going to take a guess, is the first value of 1127. We'll see if that's right or not. We can go look at our code for that compute weekly average, and the code for producing one of the dates just takes the very first date value out of the very first record. So that does make sense that 1127 should be the value then. Now, the average closing price for 1130 is obviously going to be just the value for 1130, so let's copy that. Remember, that's the 5th column. So for 1130, the value should be a floating point, 24.69001. Then the average closing price for 1127, that'll be a bit more complicated because there are 2 values involved. We have 24.79 and then all this, and then also 24.940001. So we could cheat, and I've already copied and pasted these into Spotlight here in Mac to perform a calculation and give me the value. So here's the 2 values for that second week, and I've averaged those out. The averaged out value is 24.865001. So this should be the expected value. The expected averages should be this array. What we can do then is call assert, and then instead of equal, we need to call deep equal to compare the items inside of these arrays. So we'll compare the actual values that come out of computing the weekly average, so this variable right here. We'll compare that deeply with the expected averages. So we'll go through the arrays and compare the keys on each of the objects to make sure everything matches up. Now if we come over to the terminal and we run npm test again, we get a little bit of a bug back. So if we look at what's going on here, we have a couple of messages here. First off, we expected that key 2015-1127 and then key 2015-1130. So this we expected to deep equal this. And the thing I notice is that the dates are flipped around. So the ordering matters of the elements inside of the array. So we need to flip around our expectation to match what comes out of our calculate weekly average. Now we didn't explicitly set an order in there, but we can go ahead and match the order that's coming back out. Remember, there's a group by involved in there. So it's reordering records, obviously. If we wanted to, we could go into compute weekly averages and force a sort at the end of this chain. And we could sort by the key value. I won't do that. You could do that if you wanted to guarantee the order that comes out of that function is sorted. But if we flip those around in our expectation now, come back to the terminal, run our tests again, looks like our tests are passing now. So that's how easy it can be to write some assertions that we can automatically run to make sure that our shell script behaves as expected. So we can slice out a little bit of logic in our shell script and put some tests around it, which can be really helpful. Can add some confidence to what we're doing. Then if we come along and change something, and we accidentally forget to compute an average, if we run our tests again, our test will tell us that something is going wrong here. And you can see now we have an array instead of just a single average value in both of these cases. So we could go update our test if that was the intent to change how our shell script worked, or we could go and fix our shell script, run our tests again, and we can see they're passing so we know everything's okay. We have reached the end of the course, and I really hope you enjoyed things and enjoyed sharing this with you. Before we wrap up, though, I'd like to point you at a few more resources, topics I didn't have time to cover in this course without making it a 30 or 40-hour course, which I'm sure you wouldn't have wanted to watch through. Instead, I'm going to give you some pointers here for things you can turn to, perhaps when you run into certain situations or when your interest in this topic grows. First, keep in mind all the documentation for Node.js is really helpful, especially the API documentation, which you can find online, to learn more about the APIs and modules that are built into Node.js that you can take advantage of. Many of these provide all the functionality you need to start writing shell scripts. In particular, aside from using the exec function that's built into ShellJS, which is really convenient actually for shelling out and executing some external code, you might also come and take a look at the process APIs inside of Node.js and also the child processes module for more ways that you can interact with external processes and also for how you can shell out and interact with those processes in a much more advanced way than perhaps the exec function with ShellJS if that doesn't suit your needs. For example, you can take a look at the asynchronous process creation and the various different methods with which you can spawn other processes. Also, if you aren't familiar with streams in Node.js, I would encourage you to learn a bit about streams inside of Node.js. The API here for streams does a great job of explaining how to read and write from streams, even how to create streams. This will be especially helpful if you're processing files that are extremely large and you can't simply read the contents into memory to manipulate the contents and then write it out, and you have to do some type of on-the-fly transformation. So I'd encourage you to look at streams in that case. Daily.js is one of my favorite JavaScript sites. It's no longer an active blog, but it has a rich history of information you can access. And I'd specifically encourage you to Google this site for Node-Unix. You'll find many different articles that go into depth about how you can think about JavaScript as an environment to be writing processes that follow the Unix philosophy. You'll even see more information, for example, if you wanted to start writing daemons with your shell scripts, so turning your shell scripts into perhaps a service that just executes all the time. So I'd encourage you to check out these articles and read through these for further information. I'd encourage you to keep an eye out for support of ES6 and Node.js. Some of these features are already available, for example, arrow functions. We also saw template strings in this course. But keep an eye out for some of these new language constructs because these can really help you when you're writing shell scripts. For example, keep an eye out for the built-in support for promises in ES6. Promises are a great alternative to the insanity of nesting callbacks, some of which we saw in this course, but much of which we obviated the need for callbacks by using synchronous functions instead. There aren't always synchronous versions of functions. Sometimes there are versions that return promises, though, that allow you to chain together a series of operations. Promises at least keep things to one level of nesting. Though they don't entirely solve the problem with callbacks, they help out quite a bit. What I'd really encourage you to keep an eye out for in ES7, so coming in 2016, ES 2016, are the async and await constructs in the JavaScript language. Here at the top is an example of a series of promises chained together. There are two different asynchronous calls here, one to db.post. This is the callback here, more or less. And then db.get, well, the callback would normally have been this right here. So you can see how promises chain together and only keep one level of nesting. The really neat thing in ES7 will be the await and the async constructs that'll allow you to write code as if it were synchronous calls. You can see the same code here in the top is repeated down the bottom with async and await. And as you can see, you can await the result of calling db.post. And it's almost magic as if then the result shows up in this variable. And you can now write code that looks like it's synchronous code, even though under the hood, it perhaps is executing asynchronously. And it's at least executing under the hood with promises behind the scenes. So async await will work with the ES6 promises and allow you to rewrite and simplify code rather drastically. If you want to take advantage of something like this today, you can start to look at tools like Babel to run your scripts instead of using Node to run your scripts. There's a Node-Babel that allows you to run Node.js scripts using newer language constructs, and I'll allow you to explore that on your own. The website for that is babeljs.io. You can come out here and learn a bit more about using some of the next generation of JavaScript today, even with Node.js. This will be especially helpful in cases where you're perhaps calling out to a web service, getting some results back, parsing those results with an API that's asynchronous, perhaps writing those results out to another service or a database. You can see there are many asynchronous operations that could lead to many levels of nesting and get out of control rather quickly. That's where async await constructs could really help out your shell scripts. And that's it for the resources. Again, I hope you enjoyed this course.